Right, good day guys, and welcome to today's video. So in today's video we're actually going to be talking about just a few things, and also I want to say well done to every one of us who have come this far in this tutorial training. I know for sure that our future project will just tell us thank you, all right, because we're going to do much more and much better in our future project, and also our clients will be well pleased, and also they will call you back, all right, because you're going to give quality to them. All right. So now, I'm going to do just a few things in this project two. Project two is actually just it's not too much of a different project. All right. It's just the same approach, but it's just for us to just touch another view of structural design. Let's touch an identical structure. All right, an identical structure that is having let's say two-story buildings. All right, so that's the main distinction between project one and project two. So let's just touch the bit and then we are done with this, and then comes your final project before your certification. All right, so if you're cool with that, let's go ahead into our AutoCAD and let's start our general arrangement. All right. All right, so here we are, and done. Let's open our AutoCAD. Good. Okay, so this was project one, and then also this is our work, right? So we are just going to touching the foundation layout for project two and the part base for project two. The rest is just the same detailing and all of the same process. All right, so I will leave that to you guys. You can just complete that up. All right, we're going to touching this part and then this part. Why are we going to be touching just this part? Because the differences between your two-story building and your story and a story building is actually the bottom load. All right, the bottom load and the additional floor to it, and you adding an additional floor to it is what results to a higher bottom load. So let's see how high this bottom load becomes, and let's see the part basis that we first should hit. That's the reason we are going to be touching project two. All right, so talking about those two in particular, we're just going to be touching the foundation layout and also the part base detailing. So that means we are going to be doing part base analysis, part base design, and part base detailing, and also we're going to be doing just foundation layout and foundation detailing. All right, so these two things is what we are going to touch here. Then we are done with particular project two, and afterwards, as I said earlier, comes your project. All right, so let's go ahead and let's do our general arrangement for project two. So up here we go. I actually sent this to you guys, so check it out. This is where we are now. You can see how this is. It's not looking like, you can see. So I will teach you how to clear this work up to become very explicit. So like maybe you'll be able to do um your general arrangement with ease. All right. So the first thing I'm going to be doing is I'm going to put off irrelevant stuff. So I'll put off my dimensions. You can see it here. Look at this place off. So you put off your dimensions. Everything that's irrelevant, put off. So this will be going off. Yes. Oh no. Okay, some walls had to go, but let's see. Okay, so beneath here, if you go to, let's see, don't worry, let's just copy all of these downwards, and then let's copy all of these that we are having here. Just copy. They are all identical plans, all right? They are the same. They are all identical plans and they are the same, but let's just copy all of them. Let's put it on back. All right, so now if you see in the ground floor, we are having a car park here, right? Obviously, we're having a car park here. So if you go back to your ground floor here, you will see that you're having what? A car park here, right? In between these two spaces, you have a car park here, you have a car park here, right? So go back again and let's see. That means two cars are parked in this particular space, and just a single car is parked in this space. Okay, no problem. So that makes it not actually identical, but if you check properly, you see that we have cantilevers too attached to it. So I'm going to just bring something up to you guys and then we'll check it out. All right. So okay, let's check some stuff out. So you can see that we are having cantilever here. So from second floor upward, if you guess now what we are doing, we are actually checking our workout and see and become friendly with our design. All right. So first of all, you become friends with what your architectural design. So you go through it, check and ensure that everything the architectural design is portraying is okay before you go ahead and start doing your structural design. All right. So now we have a cantilever here, so that means from this place, from the first floor upwards, you'll be having a cantilever and they are both the same. All right, so that means it's only the ground floor that had a little difference, so let's take note of that. Let's go to this point. You can see it here. This is the approach view, so you can see still seeing here cantilever is here. Come to this point, still seeing cantilever is here. Okay, okay, these are the section view. So we have cantilever in some places, and that cantilever is majorly at the front of the building. If you check it out very well, this is the front of the building, and also we have one at the side, right? We have one at the side. So how do we know it is a cantilever? Don't worry, we are going to be superimposing and checking it out. So that's how we know, right? But you can see from the elevation that we have cantilevers, but you don't know the side that they are actually. But for me, I'm already seeing the side that they are already. But in case you don't understand, we are going to be superimposing so you can get it properly. All right. So now, how do we go about superimposing? Most of the times, the staircase is one of the most common points amidst high-rise buildings. Let's say, okay, this is not actually an high-rise building, but if you have an high-rise building, staircase is mostly sometimes the common point. So what we are going to do here is just to locate staircase area. Let's say this is our staircase area, right? So immediately after the car park space, we'll be having our staircase area. So we'll go ahead. So this is our staircase area. So what I will do now is just to superimpose and see what I'm having. All right. So I will do what? I will superimpose to see what I am having. So I'm going to copy this. I'll copy this, copy, and then pick my staircase area as reference point and then drag to this point and let's see. You can see that they're the same, right? So okay, let's do this before we superimpose to check. Let's just convert everything here to a different color so you see it very, very well. All right, so let's say we are going with everything here with that color. So when I actually bring this, superimpose this, you will now see it very, very well. So you can see where you have cantilevers. All right, so we have this here. So you can see we are having a cantilever here, we are having a cantilever here. Others are same. We are having another cantilever here. All right, so you can see that we have cantilever here, we have a cantilever. There's no cantilever here. All right, you can see the ground floor line member. We have one here. So there is a cantilever here, there is a cantilever here, and there is a cantilever here. So what I'm going to do now, I'm just going to undo this. All right, I will just undo totally, and then I will copy this downwards first because I want to have a copy of that my superimposition. All right, so then I will just go ahead and do the same thing I did earlier on. All right, so I can have a copy of my superimposition and then I can make reference to it as time goes on. All right, so I'm just going to copy this, my staircase area as reference point, and then I'll place it here. All right, so now we can see what we are having here, right? So you can see, okay. So what you are going to be doing here now, these walls, they are 225 wall. So majorly, we are going to be checking the span of our cantilevers. All right, we're going to be doing what? We're going to be checking the span of our cantilevers. So I'm going to just measure quickly to know the span on time. All right, so I can actually just use my grid cycle. Use my grid cycle here. Just draw it across where it ought to be. Remember, we'll put it off, so some stuff will left the design. So I'll just put it here, just to take note of what I am working on. That's the span of the cantilever. All right. So I'll put another here, and then you can see that I want to note this span too. So I will surely have to put another grid here. All right, so for this one too, let's check. Let's look at these two cycles here. Actually the grid that we are going to be using to get it. So that's the grid cycle we are going to be using to get it. So I'm just going to use this line and then drag downwards to this point, and the same goes for the other one. All right, so when you join again, I'm just going to copy this and put it here. All right, so you can see, so we'll take note of the span of the cantilever. Oh no, we need another one here to actually get some stuff. So I'm going to just copy all of this, copy, and then okay, let me not copy two, let me just copy only one of them. All right, so I'm just going to copy only one of them, and then I'll just put one here because we are having one here. Okay, I think only one will do, so I'll just select this and drag it forward. All right, so now we can easily do our measurement and check from center to center. All right, so we have 1.5 meters, 1.5 meters. So the span of this particular cantilever is 1.5 meters. All right, so go upwards and then do measurement for this one and check again. This one is what? Same 1.5 meter cantilever. So you do measurement for the last one. This one is what? 1.5 meter cantilever. All right, so you can see that everything we're having here, they are all the same span. So that make it very, very easy for us. So we already know where we have our cantilever. Just to go ahead and start doing our general arrangement for the ground floor first. Then when we get to ProtaStructure, we can start inserting all other components in the model. All right, so that's why it's very, very important to superimpose to get what you want. We are still going to superimpose again when we successfully place our columns. All right, so now let's go ahead and work on our ground floor first. So you can see this here. These are columns, right? They're already placed from the architectural design. Remember, this is a car park, so there's already a size of column from the architectural design. So as an engineer, as a structural engineer, you have no right to alter an architectural design given to you, except you are given the permission from the architect. All right. And also, before the architect can alter a brief, he must be given permission from the client. So you see how it goes. All right. So now this is it. So we're having column here automatically. So what we are going to be doing is to create this particular type of column, this type of column, also this type of column, and then we'll go with our normal type of column for this other part of the building. All right, so let's go ahead and let's do our general arrangement for this particular project too. Okay, so now we are going to go ahead and put everything that we don't need off or delete them. So for this, I'm going to take this off. All right, I'm going to take all of these architectural grids off, and then this session, I'm just going to take all of that off. And then what is for you have to also take note of the paneling you want to work with. All right, you have to take note of the paneling method you want to work with. So I'm already seeing a view here. So this will be one panel, but let's measure first. Let's see, but there's no much load coming on it, but 6 meters. Okay, this can be one panel. All right, this be one panel, and also the staircase one panel, and this one will be one panel also. So for this, we are going to take here like this as one panel, and then we'll take this space as one panel and this other space as one panel. All right, so let's go ahead and do that, because remember, this general arrangement, your paneling is very important because of slab. So I'm going to go ahead and delete everything in this space, left with that space alone. The same goes for this. I'll delete everything I have here. All right, left with this space. So you see it. Then for this, the same goes with this. All right, I'm just going to delete all the components I have here. Even the text will go for it. So remember, this one too is a column, so you have to take note of that. It's a column too. All right, so you do all of this, and then you have this space to work with as a panel. This space to work with as a panel. And then all of this will go. All right. And also, all of this will go. So we are having this. Okay. All right. So we are going to take this off too. Cool. So yep. So now let's go ahead and let's clean this up and make it a total complete line. All right. You can see that a wall came out here, but you can leave that wall aside first. That's a wall. All right. You can leave it aside and just go ahead. Okay. So I'm going to extend this. So we're just going to leave all this stuff is a wall. So delete this and click this line, extend this to this point, and the same goes with this, extend this. All right, so you delete this, all of this, let's see, from this place, delete this. Let's see. Okay, I just delete all of this, and then click this line, and then you come back, extend. All right, so this extend this. This one too, extend it. Okay, as planned earlier. So we have this one here too. Delete this. All right, so you select this and just intersect it. Okay, the same goes for this too. All right, the same goes for this. So we're having these two panel here already, panel one, panel two. All right, so we are going to just drag this upward and then use that as our extension reference line. So we can have that there. So you can see that the column actually went inside and not outside. So we can take note of that. All right. So should we leave this like this, or should we divide it into panel? Let's check the dimension first, because this is a three-story building, so you have to be very, very careful. All right. Okay. We'll be having a column here and a column here, so it's not too long for a beam, and also it's not too wide. The area is not too much for a slab. It's just a one-way slab. All right. For obviously, it's a one-way slab. So 1 meter, 1.2 meter is not too much. All right. So now I'm going to select this. Don't worry. Our slab analysis will give us the results and we'll see what we have, not just by mouth. All right. So if it's too much, then we'll just go back and work on it. So I'm just going to delete all of this and then click this. Good. So I'm going to select all of this and extend our lines. So we're having this here. All right. So I'm going to click the last line. Oh, just go ahead and extend like that. Good. So you see it. So I'm do the same here. Extend this. Good. And also I'm going to use. Let me click this wall and see walls. So let me use the same layer with my architectural design for the walls. Okay, so this is it here. So I'm just going to work with layer, very important. So I'll drag this here and drag this here. All right, I just want to form my paneling first while I convert this wall to beams, because they are all beams and not walls. All right, so let's get that clear. So let me just get my paneling right before I convert these wall lines to beams. So now you can see that our paneling, we are done with it. All right, so we have panel 1, panel 2, panel 3, panel 4. This one is a staircase area, panel 5, panel 6. So we are good to go for this particular part. That's for the ground floor. All right, for the ground floor. But for the first floor, we are going to be having additional 3 panels. Guess the 3 panels are coming from where? The 3 panels are coming from the cantilever from this side. Look at it here. This side, and this side. So that making it 8 panels. All right. So now we are having this already. Let's go ahead and convert all of this first of all to our beams. All right. So just do that right away, and then go to your beams. Where do we have our beam? Where do we have our beam? Where is it? Okay, beam. Is this okay? Let's just put it on. Let's see. Okay, this is it. So for this, you just work with by layer. Everything will just go back to what we want it to be if we actually work by layer. So we just convert everything. Oh, by layer we are having this. Let me even see the size by layer. Okay, that should be 0.5. Okay, that's it. Okay, let me convert this to by layer. That corrects it. So everything is now cool. So take note, we are having a rectangular column here, another one here, another one here, and another one here, and we are having another one here. So making 5 rectangular columns. All right, so let's go ahead and let's place the major columns first, because the one that come with architectural design is actually your major columns. All right, so let's go ahead and place that. I'm just going to just draw, I believe it's 450. Okay, let's measure. Okay, we're having 450. So we're just going to go ahead and draw. We have length 450. And then hit your tab key to go to the next box. We have the breadth 225. All right, so this is what we are having. So I'm just going to hash inside. I'm going to do what? Hash inside solid, and then I'll just go with by layer. Okay, let me go with the layer column. Or let's go ahead and just hash, and then we'll convert later. All right, hash inside, and then we can easily convert this to a column layer. So put this here so you can see. So I'm just going to copy this and place it where it should be. We have one here. You can see it. We have another here. We have another one here. We also have another one here, and also this one is not in the same orientation. So I'm just going to rotate this. Rotate by 90 degrees, give us what we are looking for. So I'm going to move this. Then I'll place it where it ought to be at this point. All right, so we are done with this particular type of column. So let's go ahead and then draw our normal column, that's 225 by 225. All right, so I'm going to hash inside here, and then I'll convert it to the column. I'll convert it to what? The column. All right, so we're having this here. So I'm just going to move this to one of it, and then from there we copy and place. So I'll just place it for easier representation. I'm just going to place it at where two walls meet. That's the safest place to place at first. All right, before you start doing other stuff. So I'm going to place one there, and then I'm placing one here. I'm placing one here. Okay, I'm placing another here. Also, I'm placing another one here, and also one here, and then one here. So now basically we are done placing our columns. we have our beams too. Let's go ahead and place our grid lines. All right, let's go ahead and do what? Place our grid lines. All right, so now for the grid lines, I'll just go ahead and locate the grid line with normal we created here before, right? Remember I told you guys you can draw on the same interface. So we are drawing on the same interface, you can do it. So by layer, that's what we are working with, by layer. So let's go ahead and just we can just offset one of these 112.5 to the middle. All right, so we can convert this to our grid line. So you just put this inside your grid line layer, you converted it already. So put it here, and then by layer, this one by layer, and this one by layer. All right, so you can just extend it upwards a bit, and the same goes for this particular aspect forward a bit. And then I'm just going to copy to different vertical walls. You can see to different vertical walls. We have another one here. Okay, then I'm going to copy to this point, to this vertical wall here. All right, so we have just 4 vertical walls. Let's go ahead and copy the horizontal. I believe that is much. Okay, so we have this one here, and then I'm going to click this, convert it to grid line. So I'll convert this to grid line here, and then I can click and also move to this point, and then I'll move to this point. So we'll go ahead and then start copying every one of it. Okay, no, that was wrong. That was wrong. Let's remove it quickly. All right, because it's going to affect our placement of columns in ProtaStructure. So I'm going to copy this rightly, copy, and then I will just put it here. Put another one here. You can see the midpoint showing. Another one here. All right. So I'll put another one here. Also, I'm going to put another one here, and I'll put the last one here. You see it, right? So this is what we are having. So what we are going to do now, we are going to ensure that we have uniform extension beyond the walls, all right, of our grid line. So I'm going to make an offset of 3 meters away, and then we can now trim and have uniform extension. So you can see from this point 3 meters away, from this point 3 meters away, and then from this point 3 meters away. So we can trim this first because, all right, so you can delete this. We're having uniform grid grid extension in this particular direction. So I'm going to just drag this line forward, and then I will trim all of this too. So you can delete this. The same goes for this, but this one doesn't actually need any of that. It needs extension and not trimming. So I'm going to just extend all of this to this point, and then this line will go. So we are left with the last one. We just do the same for the last one, this, and also this. So we're going to just trim it up and then delete all of this. You understand? So now we are having our column intact and our grid intact, and also our beams and also what, our paneling. All right, so now it's time to head on, and then before we actually head on to ProtaStructure, you will actually have to open a new space. All right, so this is our new space. Copy from copy from this point, copy all your work, and then Ctrl C, and then you Ctrl V in this space, paste. So you can see your work. We are having this work here. You can check your layers, beam, column, grid line. Everything is actually what, intact. So now you are going to save this work as a DSF file. All right, you're going to do what? You're going to save this work as a DSF file. So I'm just going to save as drawing, and then I'll go with my DSF file. Enter decimal place. Okay, you see 0 to 16. Okay, they are saying okay, let's see. let's say 10. Let's save it under document drawing 1. All right, so you save on that document. You can yours might have a different saving format. All right, AutoCAD sometimes change it, so don't worry about that. So I'm just going to save my work first, and then I will go back into my document, and I have my drawing 1 DSF file. Let's confirm it that it is here. So we're having it here, saved when 6/27. So we are having it here. Look at it. Drawing 1 DSF file. So I'm going to open it to confirm. Look at it. It's the same file. So we can go ahead and let's start working on our ProtaStructure. Let's model this particular structure completely and then do our analysis. And that's that. We get our bottom load for each column and design our part base. All right. So if that's cool, see you guys in the next video. We're going to be doing modeling in ProtaStructure. All right. All right, so guys, welcome to this course video. So in today's course video, we're actually going to be doing modeling and analysis in ProtaStructure. All right, so let's go. So the first thing you do, as usual, so our custom is you open your ProtaStructure, and before you open your ProtaStructure, you have to ensure that you saved your work into what DSF file. All right, as you did the previous, it's the same method you apply in doing this one. All right, so now we just open ProtaStructure. So you wait a bit for it to open. All right. So you just cancel this if you're not interested in what they are trying to sell to you. Okay. So let's change this to, let's say, project 2, right? We already have project 1 there. So here you say project 2, right? Project 2. Okay. Project 2, right? So just click OK and then you save it like that. So you pick your UK BS8110 because that's what you're using, British standard. So you open it. So it depends on the country you are actually, but for this country, I'm going to be going with our British standard, all right? And most African countries go with British standard. Um, okay, so here we are. So the first thing we are going to be doing here is we are going to be importing our DSF file into our work so we can start doing our work immediately. So now, you come to where you have external reference drawing, right? So you click it. And then wait a bit. So this is what we are going to be having this dialog box pop up. So you click your load DSF file. So you click it, and then for yours, just go to where you actually placed yours. So this is mine here. So I'm going to open it and then leave it because my dimension is in millimeter, right? So click OK, and then you just go. When you are done clicking OK, go to import members, click it, and then click import as is. Select grid line, select grid line. So read the as label from text. Click it for it to be read. So import columns, click columns and do the same for this. So just click OK and then just do your check out the model. All right, check out the building model to see if there's any error or overlapping as this. So let's just start it. You can see no error. So in a case where you have error, why try to do yours? Just ensure that you correct it before you go on. All right, so that's that. So you can close this right away, and I think we are done. So you can close this. So here we are having what? The columns and the grid lines. So now we are good to go, right? We are actually what? Good to go. So the next thing we are going to be doing here is we are going to just come to window and then arrange window, make it two windows, which is your plan view and 3D view. All right. So look at what we're having. So you already know why I'm doing this. So we're able to see a replica of the 3D view as you work on the plan view. You understand? All right. If you don't get it, please ask questions. All right. Very, very important. So now the next thing we are going to be doing after placing column and grid line is to what? To place our beams, right? We are going to do what? We are going to be placing our beams. Okay, so here we are. So now, if you notice, the main reason I actually picked this as our project 2 is because of this rectangular column you see here. All right, because of that actually. All right, so this rectangular column, you can actually create them in this particular in your what do you call it. Okay, let's try to do something. I want to just show you guys the reason I actually chose project 2. Let me show you how you can just create this particular column and orient it very well to your own taste. All right, I don't know, so if that's okay, let's go ahead and let's do that. So I'm just gonna just work on somewhere roughly. So let's pick this point. I believe there's this point here, so let's click and let's confirm. Okay, that's it. So it's this point here and it's this point here. So what I'm going to do now is to click my column. You see it. So we are having 230 by 230, right, as the column size, right? So you can see that we are having it to as 9. Okay, so what I'm going to be doing here right now is we are going to just, for my B1, if you check properly, you will see that we are having 230 for B1 and B2 is 230 for B1 and B2 is what 230 also. So let's change this to what we want. Let's say 450 and let's insert it here. So you can see the point. It's actually showing that it's centralized, right? It's what? Centralized. Let's change this one to 0, the centricity. Okay. Sorry. Okay. So you can see that it's majorly centralized now. So what I'm going to be, you can see how it is now. Look at the orientation. Look how it is now. So you can see that if you place it, you are placing it you are placing it symmetrically. Both sides are equal. But in a case where you don't want to place it like this, you want to place it like the way you're having it here. Look at this one. You want to place it like this. All right, not symmetrical, but you want it to be half of half. All right. So that means you're having 225 in one side and 225 in the other side. So you want to have 112.5 in one side, and you want to have 112.5 plus 25 in the other side. I don't know if you get it. All right. So now what you will do is you will go and you will subtract 450 minus 112.5. That's the first thing you are going to do. All right. So if that's okay, let's see how we can get that done. Okay. I'm going to do some test running. But let's see, 112.5 plus 225. What is going to give us? 112.5 plus 225. That will give us 337.5, I think. 225, yeah, 337.5, right? So now we're going to do some test running. Let me show you how you get it. It's not something you get at when just do some test running to know if what you're doing is okay. So we're going to be editing this bit by bit. So we have it 450 here. The first thing I'm going to be doing is insert 112.5 here and see the reflection. You can see it. It's so tiny, right? So that means our working is not here. So change it back to 230. All right, so it's actually maintained the size that we're working with before. So whatever we are changing, we're not going to be touching B1 or B2. So everything we're going to be doing will be in this eccentricity. All right, so now we're going to be having 112.5 and let's see what it reflects. You see it, right? You see it. But if I change this to 0, you will see what it reflects. That means what we actually want is this one here. So 112.5 will give us this direction. Oh no, sorry, change to 0. This one should be minus 112.5. Good. 0.5. I think that will give us what we're looking for. Look at it. So you see it, right? So this one is actually talking about the horizontal aspect, while this one is talking about movement in the vertical direction. I don't know if you get it. Movement where? In the vertical direction. If I make this one 0 and I make this one 112.5, you can see the movement. Look at it. There is a movement, right? So if I make this one, let's say, let me make this one 230. Let's see what it will portray. So you see, look at the movement. So if we make this one 0, it takes us back to the middle. You see it, right? So that's how it works. So you're working with this one if you want this particular orientation you are having here. All right. So that's how you work around it. So I believe most of us have gotten what I'm trying to point out to you guys. So if you want this orientation, you just put your minus, that's negative sign, showing that just like you're having, remember that this grid you are working with here is like you're having a graph. All right, you're having a graph. So this points our origin. When you walk towards this direction, walking towards this direction, you're walking towards the negative direction. Walking towards the direction, you're walking towards the positive direction. All right. So if I insert 112.5 here, I'm actually walking towards the positive direction. So most of the column size would be in the positive direction. So if I insert minus 112.5, 112.5 here, then most of each column size will be where? In the negative direction. You understand? So that's how it works. All right. So I'm going to cancel this because we don't need that. We already have our columns here. So that's one of the reasons I actually picked project 2 to explain this to you guys. So let's see more about project 2. All right, so we're having this here, so we have to do our modeling. All right, and this is actually a two-story building, which is 3 floors. You have a ground floor, you have your first floor, and you have your second floor. First floor and ground and second floor, they are both identical structures. They are both identical floors. All right, so let's let our beam all around. So what I'm going to do here is just click my beam, then I will change this to 450. And then this one will be 225, right? Okay, let's say 230, not 225, 230. All right, so I'm going to go ahead and start drawing my beam all around this particular grid. All right, so I'm going to zoom out, and then I will just start from one point to the other point. Then I will just do it like that all around. You understand? So just go like this, and then I'll go like this. You see, it as easy as that. So easy. You don't even need to stress yourself because this is the beam. You're already placing it, right? So, okay, this one too. Then this goes for this. And then just do the same here. You do the same here. And then you do the same like this. Oh, nope. No, just don't do that. Let me see. I'm gonna undo, all right, and just redo the beam for that particular region. So I'm gonna just okay, they say new beam crossing over another beam. Do you want that? Okay, yes, I want it. All right, so now we have a beam connecting. I think we have a beam connecting this point and this point, and also we have a beam around here. Let's go and check our AutoCAD to see how we did our general arrangement. Okay, so we're actually done. So let's go back. We are done with that. So everything here is cool. So you can see the replica version in your 3D view, right? So this is the replica version, right? Okay, so that make us go into our slab placement. So what you just do, I don't need to do much setting in the slab because you are still going to do analysis for the slab, remember? Right. So I'm going to click this slab and then I'm just going to do little editing. 150. Cover should be 25. So my load for my slab, I'm going to be using the load we actually used. Okay, the dead load we actually calculated. That should be 5.37 or so. Let's go and check. So I'm just going to go back to our guide. All right. So I'll go back to our guide and just see. Okay. Mm, let's see where we placed it. So I think our guide should be here. Module 1 introduction, module 1 lecture 2 introduction, module 1 introduction to structural elaboration. Okay, let's see this. Okay, this is it. So let's go to our slab and let's see the load that we're working with, right? Um, slab. Where are you? Okay, we are in slab already. So we actually work with let's see. Okay, 5.7, right? So look at it here. Total dead load 5.0, 5.7. For live load for residential, we are going 1.5. All right. So And go back into your ProtaStructure and then insert what 5.7 here, right? 5.7, right? And for your impose load, you can just right click. Look how I did it. You can right click and then choose general domestic use 1.5. So for your self weight 3.6, okay, general load, so everything is cool here, right? So you can go ahead and start inserting your slab. All right. Okay, so I'm going to start inserting the slab from this place. We have one there, we have another there, we have another here. Let's check where we have our staircase region so I don't put our slab there. Okay, this is our staircase region, right? Okay, so this is our staircase region. So let's go back. So this place you can put the slab there and this place. All right, so now I want to point something out to us. Remember that this is our first floor automatically, right? So for our first floor, we are actually having a cantilever, right? We're actually having what? A cantilever. So we are going to go back to AutoCAD and then um, we are going to be working with the cantilevers. Let's see where they are. So I think okay, this is one of the cantilevers. This is another one. Let me see if I superimpose just for me to know the dimension. All right, if we can know the dimension, then there's no problem. All right, so this one did justice to it. All right, so this is a cantilever, this is a cantilever, and this is a cantilever. So what we want to know is the dimension. So this is the major grid line for this particular wall here. All right, so from this grid to the cantilever, we'll be having 1.5 meters. Look at it here. Look at it. There's a grid. From this grid to this cantilever, we'll be having 1.5. Look at it here. And also from this particular grid to this, we'll be having same 1.3. Okay, we're having 1.3, we're having 1.5 here. Let me check very well. Okay, it's not 1.3, it's actually 1.5. Let's measure. Yeah, so yeah, you can see it 1.5, right? So I think you not get it clear. We have 1.5. See it, right? 1.5. So the same goes for this other cantilever here. From this point to this point, we're having a cantilever in this particular region. So if we measure it, we're having same 1.5, right? 1.5. So you can see it. So what should we do now? Just to go back here and make an we are not actually going to be using this again because we're already modeling in ProtaStructure. So just to import the flaws that we actually corrected and then bring it back into AutoCAD and do our general detailing. All right, so we can actually just go directly to ProtaStructure and then continue what we were doing before. So I can click this particular grid line and then I'll just select and offset axis towards this region. I'll just zoom in very well and then a stretch. So I'm just going to be very careful. Let's zoom in very well. The more you zoom in, the more it reduces the distance in which it moved. That's the values in which it moved at intervals. So we have 1.5 here, right? So from here to here again, click this one and make an offset towards this region. We'll be having 1.5 again, right? So let's zoom in, having 1.5, right? So from this point to, I think, do we have any cantilever around this region? I don't think so. We don't. So we'll check it, all right, to be very sure. So make an offset again of what 1.5. Okay, so let's check it very well to see. Do we have any cantilever of such? Okay, there's none. There's none actually. There's none here. No cantilever of such. All right. So okay. So you can see it. So this is what we are having here. We have a cantilever here. The cantilever went like this, and then we now have another single cantilever here. All right. So what we're going to be doing right now is just we're going to be inserting the cantilever right away because we are having cantilever at this particular end. Understand? We're having it here. So it's at the first floor. So we have to insert it right away. So what I'm going to do now is just to click the slab and then change this to 12. That's this is our cantilever. All right, the 12th one. Click this and then we already have our general settings in that load. Let's see, sorry. We already have our general settings in that. Okay. Mm, okay. So now let's see. We have the length of cantilever. We have 1500, right? And then for the load, for this our parapet loading, we're gonna go with we can actually calculate this thing. So let me see. Let's do that. Okay, before we come back there. I taught you guys in the in Protect 1, but let's see, just do it here. So edit beam wall load. In doing this, I just go wall unit. So it will be automatically created here for us. All right. So we have wall unit. We have, let's say we have 3.47 plus 0.6. Okay, 2.87 plus 0.6. That should be 3.47, right? 3.47. Wall height, we are going with 3 meters. So let's see the calculation they give us. 10.41. Okay. I'm coming, please hold on. 3.47. Wall thickness. Okay, wall thickness should be 0.225 to 5. All right, having 3.87, not 3.47. It's 7 here. So let's see. This one is 3. Let's go with a higher, let's say something higher. Let's add additional loading to this load cantilever for safety. All right, this is the one is a direct value. So let's make it 4 and let's see. So we're having 15.48 here, and this one, let's see 3.47. Okay. 13.88. So we're going to go in with 14 total. This one is 2.87 plus 0.6, then plus finishing. Finishing is also 0.6. All right. Finishing is also what? 0.6. I don't know if we should add finishing. We can actually just add finishing to it. Okay, let's go back to this point. So you might be thinking, what am I saying? All right. So let's go and do our calculation. Um, where is it? Okay, so you can see it. Concrete dense weight, then 2 to 5 block weight, so 2.87, right? So you can see this one here. Wall finish, both sides 0.6, then rendering 0.3. So 0.3 plus 0.9 plus 2.87. That will give us what? 3.77, right? So let's go back. I think, yeah, 2.87 plus 0.9 will give us 3.77. So we'll have to go back and then insert it 3.77. Okay, so we have to reduce this one because it's now too much. Let's just make it, we can just leave it as 15. All right, to overload the cantilever slab. So no matter the kind of load that come on it, it will be safe. All right, it's better for a slab to be overloaded than to be underloaded. It's very, very bad to be underloaded. But if it is overloaded, no matter the mistake they did later on, you just reduce about 5% from it to increase the consistency in the result. You understand? So we can leave it like this, or you can, if you think it's too much, you can go with 3.5. All right, to go to 3.2. But me, let's just go 4 meter high. All right, it's actually 3 meter, but let's go 4 meter high. So giving us what? 15.08. So let's cancel this and then go back to our slab. All right. Okay. So for loading, for the sorry, general loading, cantilever. Okay, for the length of cantilever, we have 1500, and then for the general, let's say load, parapet load, we'll be having 15. 0.1. All right, so seeing this, we are good to go. So let's just go ahead and draw our cantilever. So I'll pick a point from here, pick this point, and then I'm going to place it here. And then the same goes for this. I'm going to pick this point and drag it to this point. And let me see the result. So I'm going to place it here. You understand? So look at it here again. So you pick this point and then you pick this point and then you place it here. So right now you can successfully say that you are done placing your cantilever. So you can see the load on it. Look at it. These are parapet load. You can see it's a uniformly distributed load. You can see the symbol. So these are parapet load. All right. So now the next thing we're going to be doing is we're going to be modeling the next floor. All right, we're going to be doing what? We are going to be modeling the next floor. But there's something about this particular structure. All right, there's something about the structure. Um, it actually has an overhanging beam. Right, no cantilever at this particular point. Remember, here is a lobby. Let's go back to our AutoCAD. Let me not get you guys confused. Go back to your AutoCAD. Look at this structure. So this is why it's important to have what? Your 3D views. You see this one here, just leave it. We're not going to be doing these things. So we're just going to be working with this one directly. All right. So let's. I wish I have 3D view for this. So I don't know if I can locate it. It's actually a work from somebody. I don't think the time I was doing the work, he did not send the 3D view, did he? Okay. Let's go. Let's see if we can get the 3D view. All right. But right now, let's just do some check-ins. Um. So if you can see properly, you will see that you are having no columns going up. So this is actually a total cantilever. Both the beam is an overhanging beam, the slab is a cantilever slab. All right. So you just have to work with that. So let's go ahead and work with that. But before then, let me see if I can show you guys a 3D view. All right. So you guys will understand better what I'm trying to portray. Luckily, I was able to find the 3D view the client sent to me, plus the attached architectural design for me to do the structural design for them. Understand? So I believe with this you guys understand better. So you can see it. This is a 3D view. So you can see what we have here right now. As you can see, this is actually that support we have there. Let me show you guys. So we have some support that follow come from the structural, from the architectural. So this is support here. You can see it. So go back to that view. What I really want to show you guys is okay, support is around there. This one is just a long support. Let's see if we can actually incorporate that. Let's go back and let's see. We have one here already. Let's see the real work. Okay, it's already there. All right. So this is the support here. There's one support that ought to be here. There's another one here. Let's check properly. 2088. Okay. Okay, this is it here. Ground floor. This is a wall. This one was actually superimposed, remember? So we superimpose this one on this one. So this is the major wall here. Okay. So now if you go back to the 3D view, so you see this place that we don't have any column ranging from the ground floor to the parapet level. There's no column there. All right. This one is just majorly for design, but also acting as a column. All right. So it's also a column, but actually an architectural column. All right, it's doing something there, but we still have to design these beams independently of this column. All right, independently of this column. Only these columns that are dependent. All right, so we design these beams spanning outside from this point. Look at this point. They are overhanging beam here. You see it, right? They are all overhanging what beams. So we're going to design those beams independently. All right. But there's no column here. We are just having an overhanging beam. All right. So let's go ahead into our ProtaStructure and let's see. Okay. So now the next thing we are going to be doing here is we're going to be generating our second floor and the third floor. All right, so let's just do that before we continue. So I'm going to generate and okay, sorry, insert. Sorry, I mean insert. So insert story, I'll go with story 2. Click OK. This and the previous. Okay, we have story 2, and then insert another story, and that story will be what? Story 3, right? So story 3. Okay, so you can see. So now this is my story 1, right? So what I want to do is I want to generate my story 1 to my story 2. Okay, so then I'll generate them to my story 3. First floor, second floor, these 2, and then 3. Okay. First floor 1 to 2, second floor. Okay, so let's generate it. So I'm going to go to generate story, pick story 1, and then pick stories 2, and just click OK, and let's see the results. Okay, so this is what we are having, right? So close. This is what we are having. I want to undo for a reason. I already generated, so don't want to let me undo. No problem. So what I will do now is I'm going to delete the slabs. All right, so all my slab I'm having in my story 3. In my story 3, I'm just going to select, then hold my shift key, go to the bottom, select the last one, and then I'll delete it. Right, so I'm going to delete that off. Okay, so we have no slab there again, right? So what we're going to be having is just a beam. All right, so follow me very closely even as I go ahead and do it. Okay, so let's start from the first floor. We are going to be having a beam. Follow me very closely. All right, so what you will do now is to go to where you have this is our story 1, this story 3. Sorry, you can see where story 3 is. Look at it, this point. So anything you draw here now will be from this point onward. Go to your story 2. Look at where story 2 is, Abby. Go to your story 1. So from story 1, okay, go to your story 2. Sorry, not story 1, story 2. Okay, so from this point now, we want to draw our beams coming out from this point. All right, our overhanging beams, we'll draw them coming out. All right, so that's what we're going to do. So let's go ahead and let's quickly do that. So I'm just going to come to this point. I believe this is my story 2, right? Plan view, story 3, story 2. Okay, so now I'll just go to my beam, watching my 3D to ensure that what I'm doing is intact. So is it here? Okay, intact. So I just want something solid. Oh, this beam. Okay, we can actually cancel. Let's not do that there. Okay, let's just make it 2. Okay. From what I'm seeing, I think we need a column here. Okay. So let's insert a 230 by 230 column there. Yeah, we need a column. So go to the ground floor and insert a column there too. Okay. So we don't need one here, all right? We need one here. This one is not holding anything, but we can still put it. It's not a big deal, all right? So we can just still put it. Good. Okay. So because of majorly the overhanging beams coming out. Okay. Don't worry, everything here we're going to export it to AutoCAD, remember? So all the editing I did will actually reflect. So This one now, we'll go back to where? Story 2, right? Plan view, story 2. Okay, so we can now insert a beam here too. Slab, overlapping. Okay, okay. Okay, so there's something we actually need to do here. I'm just going to delete all my cantilever. All right, let me place the beams first where I want to place them. Then we can place the cantilevers afterwards. They might not actually be a cantilever anymore, but we'll call it a cantilever. All right, they're having a support. It might just be a slab, a one-way slab. All right, so don't worry, let's just go ahead. Mm, okay, so at this level now, this is what we are, right? So let's insert the beams. So I'm going to insert a beam here. Good. So for this one too, I'm going to insert a beam like this and another beam going like this. Let me go to that point so you guys see it properly. So you see it. So I'm going to insert another beam like this. All right. So I'm going to insert a beam here, insert a beam here, insert a beam here. Okay. So you see it, right? So this is what we're going to be having here. So the same goes for, let's just check the way we did it here. Okay, the same goes for ground floor. That's the first floor. All right, so I'm just going to go back to this floor. So plan view, this floor. All right, so we are going to be inserting beam in this floor again. So insert this beam here, and then insert this beam here, and then another beam here, beam, beam, beam here, beam here, then beam here. Okay. So I think with this, we can start inserting our slab very well. We will be cool with that. So inserting our slab now, we can actually go with this, all right, because no longer I can leave a slab. You just see everything is intact, so we can go with this here. I don't actually want something like this, but no problem. I don't want something like this. Let's see. Okay. Okay. The reason we are doing this slab is just to insert load. Remember, you still do your slab analysis in what they call it. You still do your slab analysis in RC 2000. So just to insert, make sure that all the load needed are inserted on the beams. All right. So what I'm going to be doing here is I'm actually just going to be inserting. Let me insert cantilevers. Let me just load it up. All right. Let me load it up. Let me just see for cantilevers. Um, okay. So we have okay. So all right, guys. What I'm gonna be doing here right now is something very easy, right? So we're gonna place our slab in this particular the cantilever slab around the part where we have it in this particular structure. So I want to give you a hint that will help us correct some mistakes that might come up in future perspective. So this is it here. As long as you have a rectangle enclosed by grid lines, like this one here, like this. So if I want to place my cantilever slab here, then it will just be spanning from this point to this point, this point to this point. So what do we do here? we have to ensure that we are having just only one what? One rectangular boundary. So let's give for instance, this is slab, right? You see it, right? You see it, right? You see it, right? That's just it. You have to ensure that you're having just one rectangular boundary. All right. So for this one, what we're gonna do here is, I think this place is actually, let's go to ASICs and then the stories. Let's go to our story one. Good. Let's check. Okay, this story one, right? So we are having a beam here. We are having a beam here. So basically, the reason we are having a beam here is because we are working with what? Two floors. All right. So we can actually do without placing a beam here, but I'm also going to be placing a beam here. So in this kind of loading, you can either load as a cantilever or you just load as a slab. In as much as we are still going to be doing our slab analysis, um, in RT2000 to give us what we actually want. So we can actually just load it over here and just go ahead, because the slab here is just to ensure that every load that the beam is going to be receiving is actually placed in this particular analysis. So nothing will be left untouched. Do you understand? Nothing what will be left untouched. That's the reason we are placing every single load inside this particular beams. All right, the beam, the column, they are receiving the load, because the beam and the column are the only structural elements we are going to be getting the detailed design from ProtaStructure. So we have to ensure that every load that they ought to receive come upon them. All right. So now, to get this done right away, there's a way I want us to do it. We have to reduce this grid line here to just right click, and then you will see where you have stretch axis. So you stretch, and then you come to this point, you just drag, and then you drop. Good. So now you can see, if I attempt to place a slab here, I will have to just place only one. You can see it, right? So no end up placing too many slabs. All right. So that's just it. So in case you encounter such challenge, even while you're trying to do everything that you want to do on the beam and the columns, this is how you resolve it. All right. So ensure that while you're placing your slab element, you are having just a rectangle there. Good. So if you're good, let's get going. Okay, so now if you check properly from our 3D reference drawing, let's check it. You're gonna see some things here, right? Look at this place over here. Yeah, it was cantilevered outside and everything became plain. The same thing goes on here. It was cantilevered outside, then everything became plain. So we have to reflect it in our structural drawing, right? Not just like this. So that means, let's minimize this. Go through it properly. So you see what I'm talking about. Okay, this for another building, not for this, but I think we did a structural design for this one too. That's our company. We did the same thing for this. Um, let's see. Okay, okay. So now I'm just going to minimize this, minimize it, and then the first thing I'm going to be doing here is I'm going to check the span. I'm going to check the span of this. Right, you see this one here? I will check the span. So I will have to create a separate column here and also a beam here. Let's go ahead and do it so you guys can get it properly. All right, so let's go to our level one, already in level one. So this is it. Look at this place. This place is this place. Let's click the beam. You see it here. This is the beam. All right. So now, well, we have to put a beam crossing from this cantilever beam to this cantilever beam. All right. So let's go ahead and do that first. So go to your beam, and then you are going to draw just a straight line, or you can just cut it at intersections. So you can put one here and then continue to this place. All right. So you see there, right? So that's what you're going to do. So come to this place too. This place and cross it. All right. So go to that place, and then between intersections, like this, right? Just like that. That's what you are going to do, right? Okay. So now, okay, let's just continue. Going to bring more safety to our design. You get to bring what more safety to our design. So it's going to go like this, and then it's going to go up to the end. Yes. Right. See it, right? So that's it. It's going to go up to the end. So now with this, now we can say, okay, we are having a well-stable structure, right? We have what? A stable structure. So let's cut this, and then we are going to go to our story two. So from my view, I'm just going to go view, and then click and go to story two. So we do the same thing we did for our story one in our story two. So you go to your main, the same way we just did it so sweet. Same thing here. See, right? So let's check out 3D again. This one, right? So one and story two first, then we'll now deal with the final story. All right. So this is it. So we are going to be placing columns. Doing this to ensure that we have these monopolized we have this oneness between them. We have this oneness between all structural members. All right. We have what? This oneness between all structural members. That's the reason we are doing this so that we're well connected. And this will bring more stability to the building. All right, even if it's not an high-rise building, but still it's just a two-story building. So but it's still important that you ensure that durability and stability is well done. Like it was done to an extent whereby you can say this structure is durable and this structure is stable. All right, so that's the reason we are going this far. So now point column here. Do you understand? Point column here, a point column here. So that will take us back to where? That will take us back to story one, right? So let's see plan view, story one. Good. So here we're going to put a column here. We're going to put a column here and a column here. All right. So let's go ahead and do that as fast as we can. 230, 230 here. Okay. Good. So put one here. Check. Oh no, not yet. Delete this. That take us to story two. Okay, so story two. Yeah. Yes, we're going to place in a column. So we have one here. Good. Right. You see it, right? Another at the edge. You see it, right? So you place one at this end and one at this end. You get it? We're going to be points. You see it, right? So everything will complete in no time. We're going to be doing something here right now. And what is that? We are going to copy. Let's check. Okay, let's go to our story three. Because that's where we are going to be having some work done there. Sort of work in our story three. So let's go back there. So this is it, right? So now let's see. Let's check. Okay, I think we are done checking. Okay, so now being extended to this place. Coming here from this point, being from this point. That's how we're seeing it. Right? Coming to this order. Next, being coming out here. Being from this point, yes, and then continue. Yes, then you continue. Then come to this point, just click yes. Okay. Yeah. Also, there's a column here. I'm going to place a column here. All right, guys. So we are going to go ahead and place our columns here, right? I'm just going to pick this column and I'll place one here. Then just go to my 3D view. Okay, so we have it here. We have another one here, right? Okay, so we're going to leave this part because no column will be here. Remember, no column is there. Look at it here. No column, no column, no column here too. All right, we only have one column here holding this other part. So just go back and then come to this point, column here and then a column here. So we are good to go. So this is actually what we are going to be having. All right, this is what we are going to be having. So the next thing we are going to be doing here right now is to load our beams. We're going to do what? We are going to load our beams. So what I'm going to be doing here right now is I'm not going to be treating this my story one, these beams in my story one as cantilever, the slab in this particular part of my story one and my story two, I'm not going to be treating them as a cantilever slab any longer. I'm going to treat them as my normal slab. All right, so I'm going to go ahead and then insert my slabs. So I'll go to my plan view. All right, so yeah, so this is my plan view. So I'm going to start by, this is my story one, sorry. Starting from story one, I'll start inserting my slab. So let's check if everything is intact. We have our load. Okay, good. So I'm placing a slab here, I'm placing a slab here, I'm placing a slab here, placing a slab here. I'm placing a slab here, but this is a staircase area, right? But these are landing. So the last land, that second landing. So I'm going to place a slab here too. I'm going to place a slab here. I'm going to place a slab here. So we are done with that part. Let's go to where? Our story two. Good. So story two, I'll do verbatim for my story two. So place a slab here, place a slab here, a slab here, then my second landing, a slab here, and also a slab here and a slab here. All right, so you can see it. Everything is what? Complete and intact. So the next thing we are going to be doing here is we are going to be placing our wall load, which is what is very, very important to place our wall load before we do what? Our analysis. All right, if you don't load your beams, what will the beam be carrying? You get? If you don't load your beam are carrying nothing. So you have to ensure that your beams are well loaded, your columns are well loaded. All right, let's get them loaded and let's see. So let's first of all, we are going to just start from this point, and then I'm going to expand this. You see it, we have the beam. Let me expand that of the beam. All right, okay, story one, expand. Then I will compress the column and then expand the beam. So you see it. So I'm going to click the first one first, and then I will just go to my edit wall load. Edit. Okay. So let's wait a bit. So you see it. So we are having it. Yeah. We are going to be doing what? Editing our beam wall load. All right. So you say wall unit height. What's our wall unit height? We're having a wall unit height. Let's cancel this first. Okay. So let's click the columns and just click properties. So okay. Didn't sort out the stories. Let's see. Okay, 3 meters. So the height of each story is what? 3 meters. So I'm going to cancel this. That's how you just know your height, but by default, ProtaStructure will set it to 3 meters. All right, so you don't have any stress with that. That's the normal headroom. Okay, except it goes beyond like 3.6, so you just have to edit it. All right, but for this one, it's 3 meters that we're working with. So now, okay, so just go and edit beam wall load. So we are having what here? 3 meters, right? We are having wall height, wall units weight. We have 3.77 that we're going to be using. Then for Our wall height, we have, let's say, I told you guys before that I just want to use, let's say, 4 meters. All right, let's use 4 meters. There's the reason we are going to be doing that. Let's use what? 4 meters for our wall height. Okay, so wall thickness, I'm going to go with 0.225. So I'm just going to click OK, and then, all right, where you start column. Let me see. Okay, look at it here. Okay, the wall height now is not too much. Okay, we already did, let's say, let's reduce that. I did beam wall load to 3 meters. Good. So just click OK, so everything will start. So you see it, right? It's now good. So there is something we did when we we're trying to use the cantilever method for this, but we did that check and we saw that that cantilever method will not work for the particular structure. So we have to brace it more with columns and beam. That cantilever beam down here, look at it here, this cantilever beam, we have to brace it more. So that erase the aspect of cantilever slab all around the building. All right, so that's why we don't have cantilever slab again. So we don't need our parapet load any longer. So it actually edited that in our drawing, as you can see. So I'm trying to give a summary of what we've done thus far. All right, what brought us here and the changes we made. So you understand that we made changes. All right, so let's get going. So I'm just going to be click this particular column and the beam which you've created, the beam wall load. So I'm going to just say copy beam wall load. Then I will select this column, hold my shift key down, and then hold my shift key and select the last one. Everything is selected. So you load it up. Paste, beam, copied, beam, load. Paste, copied, beam, load. So you're going to paste it here like this and click yes. You see it, right? So I actually know that there's no wall here. No wall in this place. I told you before, the reason is to load our beam. Your beam cannot just be left standing, hanging there. All right, you have to load it. You have to load what? Your beams. And you have to overload it so to give you a design that even if there are any mistake in execution, your design will still be intact and the structure will still have its durability at 100%. All right. So now there is it. So I'm just going to be doing the same for story 2. So stories, I'm going to open story 2, right? So this is my story 2. So I'm going to just let's see if we can, let me compress this and compress this and have only my story 2 being expanded. 2B1, right? So let's see if we can just paste this here. If we can't, we have to create one and then copy again. Let us see. Paste, copy, beam wall load. Yes. Okay, so good. So we've loaded our story 2 beams also. So we have to check something again. And what's that? We have to go and check our 3D view. Look at it here. We are having a short wall at the top of these beams. You see it, right? So we have to place a short wall. All right. And that short wall, we have to go back to our drawings and then we check them one after the other. The short walls, which of them, what's the height of this short wall? Then we are going to load this top beam with the height of those short walls. All right, so let's get going and let's see how we can get that done. Now the next thing we are going to be doing here is what? We are going to be creating the short walls that are going to be on this beam. That's your roof beam, right? That's going to be where? On your roof beam, according to the 3D view. Do you understand? According to the 3D view, from 3D view, you will see that there was a short wall on each of the beams, but majorly it is at the surrounding. That's the beam at the circumference. That's the beam around the circumference of the roof structure. This roof layout you see here now, around the circumference, you are having a short wall on them. But what we're going to do is we're going to place short wall on all the roof layout beams. All right. So let's go ahead and just check out the 3D view, and then you understand what I'm trying to portray in this particular video. All right. All right. So this is it. We're having our 3D view here, right? So you can see we have, look at, from, let's just zoom a bit. Okay, it's a bit blur. From this point, you have your beam around this area, right? From this point onward, you might be having a very short wall there. Even if you're not having a short wall, all these things, all these elements above this particular beam, they are load on the beam. So you have to ensure that you load the beam. So even if, let's see, I'm sure it's a very short wall that is on that particular beam, on this roof layout beams. All right. So it's a short wall. So we're going to go ahead and place short walls on all the roof layout beams to ensure that both the roof layout beams are loaded, so that it will give us an equivalent design that will be able to withstand the equivalent load we see right here. All right. So now let's go into our ProtaStructure, and then we have this here. So we are having it at what level? We are having this particular roof layout beam at level 3. All right. Plan view level 3. Good. So this is it. So I'm just going to expand that of the beam and just click one of it, and then I'm going to edit beam wall load. Okay, so there is it. So I'm going to start by inserting the wall unit width, which we are going with 3.77. Then for the wall height, we will have to confirm this wall height very well. Then we add our own to it to make it safer. All right, so in confirming that, we have to go back to our reference drawing in AutoCAD, which came from the architect. All right, so let's go ahead into AutoCAD and let's make our confirmations before we come back and insert our own height. All right, so we are just going to go straight to AutoCAD right away, right? So now look at it here. This is what we are having here. You can see this is a parapet level. If you go into your 3D view, you will see the parapet level. All right. Go back to your AutoCAD. You have those points here, right? Go to your 3D view and let's make some confirmations. That's this point here. So we have those points here, the parapet level, and we have those points here. All right. So go back here. We have the parapet level, and then we have the ceiling level, and this level is where the drop beam is going to stop. All right. So we're going to measure from this point to this point. Let's go into use our measuring tool in AutoCAD. All right, so we're going to measure this from this point to this point is what? 1950. Look at it. Let's do that again. From this point to this point is what? 1950. All right, so go back into your structure, and then you click this beam and then edit beam wall load. Okay, so I'm gonna insert the wall unit height, which is 3.77, and then I'll make my, remember we are having 2 meters, let's say 2 meters random, roughly. All right, 1950 is the actual height, but we're gonna go with 2.3, so let's say 2.3. Then we have wall thickness of what? 0.225. Good. So we just click OK, and then the wall has been created. So you just say click this right click on 3B1, because that's the beam in which you create a wall load on just now. So you're gonna create and just say where is it? Copy beam wall load. So you copy it, and then you select the second one here, and then you go down holding your shift key, select the other one. All right, holding your shift key, select the other one. So you now just right click, and then you just say paste copy beam wall load, and then you just click yes. Good. So now they are loaded with the short walls. So now we can go ahead and do our analysis and see what we've got here. All right, so let's go ahead with our analysis. All right, so my analysis, I'm just going to Control S to save my work. Then when I'm done saving my work, just same way we did the first, we're going to do the second. Now this one is a bit let's say is a bit not it's a bit advanced with new details and new info. All right, that's the only new details here is I think no, not much details, but this rectangular column, yeah, it's a new detail here that we did not do in the first project. All right, so let's go ahead with our analysis. So I'm going to click this place, and then we have all of these here. So the first thing I'm going to do here is to edit my material. All right, so edit material we have for the concrete column. Let's see, 25. Okay, then we have our okay, good 410. Then we have our rebar diameter. So I'm just going to unclick this, unclick Y13, click Y16, click Y20, click Y25, unclick Y32. All right. So we'll just have we'll have same bars, not too versatile, not too much different kind of rebars that are present in our design. We just need just three. All right, three, three, three. Okay, so we have done that of the concrete column. We don't need to do that of the slab, all right, but the concrete beam we need to do that. So okay, this one is okay. We have our rebar diameter. Then I'm going to just unclick Y10. I'm going to unclick Y13. I'm going to unclick Y16. Okay, sorry. I will leave my Y16. I will leave my Y20. I will leave my Y25 and unclick Y32. Another reason for us using these particular rebars is because they are known everywhere. You can easily access them. You can't be doing a contract in, let's say, in Nigeria, and you're going somewhere like just an example, right? You are going somewhere like Ghana to get those particular products. All right, those rebars going to Ghana. Do you know the cost? So remember, you're doing design. You are putting the cost efficiency. You are putting the durability. You are putting the stability in front of you. All right. So you have to ensure that everything can be easily accessed. No need of too much stress. Too much stress. Sorry. All right, so you have Y16, you can easily access Y16. You have Y20, you can easily access Y20. You have Y25, you can easily access Y25. All right, and all these Y13, no, you don't have to stress yourself that much. All right, because those are varieties. There are varieties, and it will be a bit complex if you're having varieties of rebars in your design. To be stressful to those executing it, or you as a consultant executing it. All right, so let's just have these theory so it would be easy for us if we are going to be consulting or even the contractors. All right, so let's go. Click OK, and then for my links, I'm just going to go with my rebar, and then I just want, okay, I think I don't want Y9, I want Y8, Y10, Y12. The rest can go. All right, so Y8, Y10, and Y12. Oh no, that's Y13, Y12. Good. So Y8, Y10, Y12. Okay. So what else are we going to edit? Nothing yet. Just leave the rest. The slab. We're going to do slab analysis in our 2000. Remember? So the same process you followed in project 1, it's the same process you're going to follow in this one. So take note. All right. So good. Click OK. And then what else are we going to edit? Okay, all these ones they are already okay. All right, unit weight of block, let's leave it like this, 4.5. It's okay. So we have model option, flanger, S and Y. So leave everything like this. They are all okay. Analysis. All right, for my analysis, I'm going to do a building model check first. I'm going to do what? I'm going to do a building model check first for my analysis. So in doing that, I'm going to click all the box. So click everything. All right. So that's it. So I'm going to just do a building model check first to see if everything that I've done in this structure, in this model, is actually intact. All right. So let's go. Okay. So we'll just click building model check. Click it. And then you start to run it. All right, you can see number of errors 0. So you have to ensure that you don't have any errors here. All right, This is very, very important. Is what is very, very important. So you don't go ahead with analysis and then you're having errors. Then you come back and do your model check. You're seeing errors. You have to do your model check first before you do your analysis. All right. If your model check is having any error, then you have to correct it before you do analysis. And then if your analysis is having a filling column, filling beam, you come back again and increase the size of columns, or you edit the design of the beams. All right. So let's go ahead. You can see mine is showing 0, so I'm good to go. It's a pass mark, so I'll just close this right away. And then before we do our analysis proper, I will have to go to my pre-analysis again, and then I will have to insert my load combination, which is very important. What is the factor of safety we are going to be using? So I'm just going to click this, and then I will just click load generator, click OK. You see it here, right? So just click OK. It's very easy. Click here, load generator, click OK, everything become insert here, and then just click OK to finish up. Good? Are we good? Yeah. So analysis. So it's time for us to do our analysis. So I'm going to click this with analysis, and then I will click this, and then all of them are being clicked already. I will leave this. I don't want too much stress. We already know what agent value is, but we don't need it, all right? Well, if we need it, we can put it, but if you don't need it, no problem. But I'm just going to leave my like this because I don't need agent value for now. So I'm just going to start it. All right, so it's already loading. Okay, so you are going to patiently wait for it. It's analyzing the structure, checking the beam, checking the columns, checking every single thing, they are intact. All right, so already analyzing. Okay, so we are good to go. Let's go ahead and see our analysis results. So I guess everybody should be here right now, so let's see it together. Good. So open it back. Okay, so post analysis. Remember, we moved from pre-analysis to model option, from model option to analysis, from analysis to post analysis. Good. See it, right? So now let's check our column wall design. This is the first one I want to check. All right, let's see. Wow. Oh, we have a failure here. Oh, I don't like this Y13. That's the problem. Okay, I know what to do. We have to do our analysis again. This Y13, Y14, you see the varieties. So it's like something went wrong, so we have to go back and edit it. I just want to see only Y16, Y20, and Y25 here. If we have Y16 here, this column will not fail. All right, we have only Y14. That was the area of the steel area required is not even up to. All right, so that's it. I'm just going to go back and still do the same thing over there. All right, so good. So follow me. This is what we see in analysis. It's called analysis. When there's a failure, you ensure that everything is correct and intact before you submit your designs for execution. All right, so we're having a problem here. We're having a problem with varieties of the bars, and we have a problem with the filling column. So we will have to ensure that we don't have these varieties. I don't even like it. It's not professional. All right. So I'm just going to go ahead now and cancel this and check the beam also. I'm going to check my beam and see. Okay, my beam is good, but let me check this beam again. If my column is having Y13, then my beam should be having Y13 too. Okay, you see this Y13? I don't want it. I don't really want it. So we're going to go back and do our analysis again. All right, we're going to do what? Analysis again. The reason for this analysis, we don't have much problem. Not much of the column are failing. All right, just one that failed, and it was because of the lesser steel area provided by Y14. Let's go back there. Look at it. The lesser steel area provided by Y14. We have 4Y14. If we have 4Y16, then this reinforcement will be able to hold the load coming on the column. Do you understand? So we have to edit this, and to be an advantage. All right. If you present this like this, now what if? So you have to present a design that is durable, sustainable, stable. All right. A design that is well presented. A design that has accuracy as its tag. Do you understand? So that's it. So we're going to do analysis again. So follow me very, very closely. All right. So no cause for alarm. Just pay attention while we resolve this. All right. So let's go. Okay. So here we are. I'm going to just cancel this for now and then go back to my pre-analysis. So I'm going to edit material. Let's check if what we did was even saved by ProtaStructure. Let's check. Okay. So it's where it's coming from, right? So Y10, I'm going to unclick it again. Y13, I don't want that. Y16, Y20, okay. Y16, Y20, and Y25. So I click OK, right? So I'll come back here. Where is my link? I'll just do what I did earlier on before my analysis, okay. So beams, Y13, okay, good. Uh, my links, okay, good. So I'm just going to click OK, and that's that. I'll go back to my analysis again, and then I will still analyze again. All right. So for this now, I'm not going to select bar. So let's see. So just leave this like don't select bars. Leave it like this. All right. So I'm going to start again and see my results. Okay. So we are done. So I'm going to click OK, and then go to my analysis. And then I'll go into my columns and let's see. Oh no, yeah. So this is it. Okay. So this is what we are having when where is this Y14 coming from? This analysis, all right. This analysis. So you have to encounter this. All right. So I'm going to exit it and go back to analysis again, and then double click this one and start again. All right. At least one option mode is set. Okay. Let's erase that. Click. Click. Click this. Click this. Okay. So let's start again. Let's see. All right. So you just hold on and let's see the results again. Okay. 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 No time will be done. Okay, I think it's done already. So just click OK and let's see in a hurry what the result is now. Okay, Y12. So this is the only problem we're having. Okay, okay, okay. We don't have our Y13 again, just Y16. Yeah, so this is it. So what I'm going to do here now, I'm just going to edit this. So let's see if they will even allow us edit it, because they can be so strict. All right, I told you they can be so strict with it. What column is this? 2C20, right? Column 2C20. 2C20. Let's try some method. If it does not work, then we have to increase the size of that column. All right, that column that is failing, we have to increase the size to make it work. Okay, let me reduce it to Y16 back. Let's say Y16 and then 2 on top. Okay, the top reinforcement, they're having problem. 2 top, you can see minus minus here. Okay, let me see. Corner 1. Let me just see. I put 2 there, and let's see this one. But I don't think you cannot edit the dimension. You have to increase it. So let's just see if we can let's put another one here, and then let's see if that will work. All right. For this one, I can just put Y12. Okay, let's remove this one. Let's just click OK and let's see. That means we have to increase this column. That's 2C20 has to be increased. Alright, so we're going to go back and increase it and then we'll come back and do it again. Alright, but let's check our beam. If our beam is doing fine. Okay, so beam is always very easy. Alright, beam is always very easy. Not too much stress for beams. Okay, let's see where it's failing. It's not failing anyway. Okay, so it's good. Alright, so everything is clicked. Everything is checked in the beam area, right? So we are going to still come back and do some editing in this beam, all right? But for now, everything is okay. So we're going to do editing. Reason being that we are thinking about the economical value of what we are doing, all right? So we have to reduce cost too and give, just you are giving quality at a cheap price, all right? So the same thing here, we are giving quality, making it cost efficient, all right? So that's just it. So I'm going to edit this, and remember we are checking our 2C20 back. 2C20, right? So 2C20. Let's see 1C20. If 1C20 is okay. Oh, 2C20. I think there's no 1C20. It's just 2C20 that is failing. Okay, let's go back. So you can see it. 2 means story 2. C20 means column number 20. So we'll just go back into our story 2 and let's see where it is there. All right. So our plan view, where is 2C20? Where are you? 2C20. Okay. So this 2C20. 2C20 is the one failing, right? So what we will do here now is just to increase the column size. I told you guys before. So I'll just click and then properties to come up and then I will increase my column size. All right. So we have B1. I'm just going to see 450 and then I'm going to update it and see. Yes. Oh no, that's not what we want. So I'm just going to hit my 230 here and then hit 450 here and update. Okay, that's not still what we want, so I'm just going to increase this. I'm just going to insert 112.5. All right, so I have to go to either direction, so I'll update it and see. Okay, that's not it, so I hit 0 here and 112.5 here. You just be alternating it until you get what you want. Oh no, that's not what we want. All right, it's called alternating. So you alternate and you get what you want. So we inserted positive 112.5 here before it went. Look at it, 112.5, and it went where? Update this direction. That means if we hit negative 112.5, it will go towards the opposite direction. Let's try it. Negative, right? Then update. Okay, so this is what we want. So let's click OK and then close. All right, so just follow up. We see that you've gotten it. So now let's go back again and let's do analysis. All right, so this is what analysis entails. You face challenges, you correct it until you get what you want. So we are going to wait again until we get our result. All right. Okay. All right, so it's done already. So I'm going to click OK. And then I will just hurry and go and check because I'm so eager to see the result. Column. Wow. What are we going to do then? It's still failing. 1.44, right? So we just need little. Let me see. 1, 1, 1, 1, 1. So this cycle, these are the rebars, all right? They're the rebars. We have 6 for this particular column, and this is the link, the ones going through the circumference, all right? What I will do here now is I'm going to try to increase it and see if ProtaStructure will give us 4.1 now. Okay. Required area of steel 255. Required steel area, supply steel area 317. Okay. 201, 255. Let's click OK. Y18, Y8 at 125. Supply steel area required for this one 255 plus. Okay, let's just see. If it does not go again, then we'll go back and do some adjustment. It's not going anywhere. It's saying I'm not going anywhere. Okay, no problem. Let's go back into our work and do some editing. All right, we are going to do some editing. So this is our 3D view, right? And this region here is where? This region here, right? So we are having it here. Look at it. So I'm going to be doing something here. Oh no, let's delete this. Let's just delete that. I think that was a mistake, because let's delete that. We're having this here now. Let's just increase this one too. So properties, 450, and let's see result minus 112.5. Update. Good. So that's it there. So this one can just be left like that. All right, I just want to see the result of what we are going to get. All right, so I'm just going to insert the beam, because now we've placed a column there with another different size, so we have to insert our beam again. To this point we have a beam, and then to this point we have a beam, right? So good. So I'm just still going to do analysis and see if we are good to go right now. Let me just check. Okay, sometimes. Okay, let me see. Yeah, let's just do analysis and let's see. Save first. Control S. Let's Control S. Go to analysis again, and analysis. Then click everything that needs to be clicked. Then start again. All right. So this is how we go about it. You have to analyze and you get what you want. Okay, so we are done again. Eagerly, let's go and check. Post analysis column. Wow, we are done. You see it, right? So This is how you go about it. We are good to go right now. All right, we are good to go. So everything is clicked. All right, this is a raw project. All right, you have to edit, analyze, check, 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 check. Why is this one failing? That's why you need manual design knowledge, and we gave you materials for it. All right, go through those materials very well so you know what to do at different points in time. From eye view, you can easily know that okay, something there's instability in particular aspect. All right, there's what instability in some particular aspect. So you have to check it very well and say, will this work? No, let's change this. Do you understand? So when you change it professionally and technically, everything will fall into place, and your design will have a pass mark. All right. So now let's go into our beam. So beam 2 has a pass mark. All right, so we have to check our beam one after the other and reduce the reinforcement, because sometimes beam can be so over designed and you spend so much on the design, like the beam, like executing the job will be so demanding price wise. So we have to edit the beam and check everything and reduce them to a barest minimum to make them cost efficient. All right. All right, so I want to do something here. Let's I forget. We check here. We place the beam here. We did not place the wall load. It's very wrong. All right, I have to go through the model again and see that we did not place it. So what going to do, I'm just going to click this, copy beam wall load, copy, and then I'm just going to click this and then hold my control key and click this, and then I'm going to paste them there. Yes, yes, good. So that's it. All right, so they've been pasted there. Look at it. So I'm just still going to do my analysis again. All right, this structural design. So I'm going to analyze again to ensure that we have the actual result before we go ahead and do our beam editing. All right, let's see if the column is actually okay, sir. All right, so I'm going to start it right away. So we are going to hold on again and let's see the result. Okay, just hold on a bit. We'll be done with this soon. Okay, so let's go and check now. Let's check. I don't want any failing column. You see, so if we did not check that, we don't know that this thing is still failing. You see it, right? So I had to just check. Okay, what happened? What changed? You see it, right? So let's close this. That 2C20 is even still failing. So we have to go back and do our editing our editing very well and get it right. All right. 2C20 is still failing. Okay. So let's just check very well. I just want to know why it's failing. Okay, now I think I have an idea why it's failing. So let's try this method. All right, let's increase these two. Let's increase it to this one. I'm going to delete this beam again and delete this beam again. Then what I will do here now, let's try this. I'm going to just properties. I'm going to insert 250, 450. Let me increase the size of this column. I'll tell you why I'm doing it very soon. See it, right? So I'm going to insert 112.5 and click update. Good. So the same goes for this one. All right. The same goes for this one. So I'm going to edit it. Properties. Okay. Properties. So I'm going to increase to 450 and then put a positive 112.5 there, then update. Okay, so the reason I'm increasing this is because I'm thinking that, let me exit. I'm thinking that this particular span is too much for this column. So we have a tiny a column here, but this column is carrying more of the load. So I want to increase this particular column to be able to balance it. So we are going to check this and let's see the result. If this particular 2C20 still fails, then we'll look for another solution to balance it to ensure that we are having an accurate design. All right. So this is it. So I'm also going to delete this one. Okay, let me check very well. Okay, this one is good. Let me see. Column, good. Column, good. So I'm just going to go back and create my beam again here. Right. So I'll create the beam again. So after creating the beam, I'm going to just click and paste copy beam one load again. Yes. All right. So let's do our analysis and let's see the result again. Let me see this. I'll have to delete this one. Let me see. Okay, it's good. So let's go back again and do analysis. This is how we check until we get what we want. All right. So I'm going to just click. Oh, okay. Let's start. Okay. So post analysis column is still failing. 2C20 is still failing. 1.33. Okay, no problem. We have to go back again and show that it's correct before we move on. All right. Let's see. Okay, so we have to take the add decision. And if you ask me, what is the add decision? The add decision is inserting a column at the middle. So let's try that aspect. All right, so I'm going to delete, okay, not that one. I'm going to delete this one. All right, so I'll delete this one and then go back to my plan view. To get excellence, you have to put in a lot of effort. All right, that's what we are doing here. Excellence is what we are pursuing, so we have to put in a lot of effort. So what I'm going to do here now is I'm just going to use this column. Let me check very well. Let me insert this beam first. So when I insert this beam, I'm going to just divide this plate into two, and then I'll place a column at the middle. I can also do the same for this point. All right, let's delete these two. I can even undo and just delete only beam wall load. All right, let me see. Okay, yes, I want to delete that beam wall load. Okay, good. So now I'm just going to insert a beam across. But before I do that, we have to delete. I'll still have to delete this column, this beam. Sorry. So I'll delete them. Good. So I'm going to make an offset, but before then, I'm just going to click and use my measure tool from this point to this point. What we have in 5490. Okay, no, that's wrong. With your shift key. Then what are we going to be having? Let me measure from middle to something. Okay. So what are you having there? 5375. Okay. So I'm just going to offset 2.6 meters away. Alright. So I'm going to click this and then offset axis and then drag to a point 2.6 meters. Okay, let's place it here. 2.488 or here. 3.488. Let's put it here. 2.488. Alright, so I'm going to place in the column there. Alright, but before the column, we have to place our beam. That's the sequence. Alright, so from this point to this point, and then we will now have a column here, right? Let's go. I would love to have my 3D view. So I'll be seeing what I'm doing. Arrange window. Okay, so this is it. So let's undo beam. I'm going to create a beam like this, and then I will have same for my level 2. I'm going to create a beam like this. Alright, so the beam is there. I'm going to just place a column at the middle. Sorry, a column at the middle. You see it, right? So that's it. Oh, the beam is not actually good. Oh, no. So delete that away, and then I will draw my beam again. Where is the beam? To this point, to this point. Okay. So I'm going to delete these two and draw the beam again. Okay. So we'll go to our level 3. Right. This level 3 plan view. Level 3. Okay. So I'm going to insert my column. Insert my column first, and then I will insert my beam from this point to this point to this point. Okay, good. So now I'm going to insert my beam wall load again. All right, so I'll copy this beam wall load, copy, and then I will just paste it here. Paste, copy beam wall load, yes. And I'll do the same for this one. Paste, copy beam wall load, yes. All right, so it has been copied and it has been pasted. So let's copy for this one of 3 meters. All right, so I'm going to just select this column, this beam, then copy beam wall load, and then I'll just copy, paste here, yes. Select everything and just paste. All right, so let's check it out again. Yeah, I believe it does not work again. We'll come back until we get it right. Until we do what? Get it right. The reason it's failing so much is because of these short walls at the top. All right, so we have to ensure that we get it right. So let's analyze again. Analysis. Click, click, click. Rebar, rebar. Good. So you can analyze structure many times until you get what you want. All right. Okay, that time has come again. These 2C20. What are we going to do with it now? 2C20 is still failing. Column 2C20 is still failing. We have to increase that size again. No problem. Let's go back. This size has to be increased. This column is still failing. Okay, let me check. Let's try something. 600. Update. Yes. Then let's say minus. Let's go to our level. So it's 2. So it's 2. Okay, let me see. Okay, let's edit it. Is it? Yeah. This one to has to increase to properties 600 update. So that one to has to increase. Wait, let's see something. Come in, let's see something. Properties 230 0. Okay, let's try something again. Click this one too. Let's change it back. Since we have put this one here, let's see, analyze again. Let's see if it will give us what we want. Alright, so we have 230 update. So we just close it and let's see if it will give us what we. Alright, so we are still trying to balance this column 2C20. It's still giving issues. Alright, so I want you to understand something. We've tried. Let me go to the back view. So this is my back view, right? Our focus scenes have been on this particular area. That's the right hand side of our, that's facing your screen, the right hand side of our 2C20, that this particular area, that's where our focus has been. So we've tried our best in this area and we're seeing that the problem is not even coming from this place, from what we've done thus far, because this demarcation of column here, trying to balance it, might solve it. All right, so if the problem was coming from this place, it would have solved it. But now let's try this other side, because we're having a cantilever beam here. Let's see if the problem is coming from this place. All right, so how do we know? We have to increase the size of this column towards this cantilever beam direction. All right, we increase it towards this cantilever beam direction. And the best way you understand this is where is from our floor plan. All right, so let's go to our floor plan. Let me delete this beam first. Yes, delete this beam first. Delete. So I'll delete this beam too. Delete. Do we need to delete this one? Okay, yes. So now this is it. All right. So I want to take us through this right now. So let's try this. I believe this one will solve it. If the left hand side resolution did not work, sorry, if the right hand side resolution did not work, then the left hand side should give us our accurate value that we're looking for. All right, because what I'm seeing here is there's there's it's actually a buckling towards the left hand side. You understand that what I'm saying here? But let's confirm first. Do you understand? It's a buckling that the load is pushing towards the left hand side, because we resolve the right hand side no matter the moment. The buckling will not be, or the load applied on that column, the buckling will not be caused by the load coming from the right hand side. It should be by the left hand side. So let's increase the column size towards the left hand side. We'll get our results. Let's see. So now I'm just going to click this and then properties. All right, I believe this is it here. 3C18. Okay, 3C18. So let's see how we increase this one towards this side, no longer towards this side again, no, towards this side. You understand? Towards this side, So now let's increase it. We have 450 here, then we have 112.5. Then you just update and let's see. So you see it, right? Towards this side. So the same thing goes for everything. So the same thing goes for this one. Cancel. Then increase this one to properties 450 112.5, update towards this side too. So with this, let's give a try again. So now I'm just going to cancel this and then I will replace my beams. Click, then beam here, right? So I'll go to here, story 2, and then place my beam, right? Then go to here again, the story 1, and then place the last beam would be deleted. So I'm going to place it here again. All right, so that's it. So now I'm just going to copy the beam wall load to ensure that every beam is loaded, which if every beam is loaded, then every column is also loaded. So I'm just going to copy this, copy beam wall load. All right, so I'm just going to paste it here, paste beam wall load, click yes, then click this one because they're not of the same height. If they are of the same height now, I would have just copied and pasted. Something is wrong here. Okay. It's okay. Nothing is wrong. So if they were the same height, I would have just copied this one and paste it here, but they're not the same height. So I have to copy the same height, copy beam wall load, and then I will paste it here. Yes. Then this one they're the same height too, so I can just paste it here. Yes. You see it, right? So there is it. So now let's do our analysis and see if the left hand side can resolve the buckling happening to that column. All right. So now I'm going to hit Ctrl S and check if everything is intact before I do my final analysis. This is it. So before we do an analysis, I want you to know something. All right. I want you to just know something. Design don't just go like that. That is why you analyze the structure. You analyze the transfer of load and balance every faulty part that might cause failure to your structure. So that's what we've done now. I just taught you that it does not just work straight like that. You have to balance it. You put everything into place. Cost efficiency into place. Stability into place. And durability into place. Even ease in execution, you put it into place. Do you understand? That's why it took us this long to get this masterpiece. So let's analyze. Analysis. All right, so I'm going to click this, click this, then rebar, and then start. So we're going to wait. Let's see the result. All right. So when we see the results, I believe it will be cool. Okay, with all eagerness, we are waiting. I know it's becoming fun. Design is fun. Analysis is fun. All right.
As long as you know the technical part of it, it becomes fun to you because just like you're playing a game, right? Trying to balance all the load. A game that is a very, very serious game. All right, so let's check our post analysis. So let's check our column. Good. You see it, right? Everything is now correct. So we balancing the left hand side. So before we were trying to balance the right hand side, right? So now we move the balancing we are trying to do, we move it to the right, to the left hand side. So that gives us our. So when you balance the right hand side of the column, and you see that okay, one thing about column is check your top, check your bottom. If the column is at the middle, check your top, check bottom, check left, check side. If the column is at the last floor, check top, check side, check and left, check right. So you should be checking every angle to see what is causing this buckling, what is causing this failure, what is causing this shear failure on this column. Do you understand? So now that's it. So we are good to go.
All right, guys. So we are actually done with our analysis of this particular structure. So we are going to be going to our total detail and extract our load so that we can design our part bases. I'm going to be touching two major parts here. The rest can be completed by you guys. So the major part I'm going to be touching, and I'll tell you the reason I'm going to be touching those major parts, is this particular part base where you are having a rectangular column and a square column. All right. And the reason I'm going to be touching this is because of the different kind of column we're having here, of which it's cool. Like you already understand it, but for some of us that might be finding it complex or finding hard to get how to go about this. All right. So just pay attention even as we do what we have to do regarding these different type of columns. All right, so we're going to take the loads at that's the column bottom load, and then we are going to start this our part base analysis in RC 2000. All right, so let's go and let's get our loads. And also the second part I'm going to be touching is I'm going to be teaching you guys how to properly analyze your staircase in RC 2000. Do you understand? How to properly analyze your staircase in RCD 2000. So those are the two parts I'm going to be touching. The rest you can finish it up because we've already done majorly all the detailing in project 1. So you can just do likewise what we did in project 1 for our detailing and also placement of work into sheet. You can do likewise and then that's all. Alright, so let's go. So I'm just going to minimize this and then I'll go to my proposal detail. That's 2018, right? So I'll wait for it to open. All right, so we have our project 2. So I'm just going to say okay. All right, so they are saying we should start by creating a new drawing. Um, okay, let me just auto generate all the drawing. All right, display load, form load, Asia load, factored. Okay, okay. So I'll just go ahead and draw it. So we are going to wait a bit so that everything will be done. Okay, so now you can choose to do it one after the other, alright? Because I want to use just the load and just want to export all the details into my AutoCAD. and then I'll start working from there. So all I need here is just my load, all right? That's all I need from this place. So from this third onward, I already have my load over here. So with this particular load, I'll be able to work on the part base. You can see how high some of the loads are. So we're able to work on the part base, and then we are done. Then we go into the staircase analysis using RC 2000. Then we are done with that. So the rest of it all, you guys can just wrap it up because I already told you guys not to go about it in project one. All right. So what I need from here now is I need this particular. Okay, let me just export everything away from this place. So we just come to this place, export DWG or DSF. So I'll just export. So drawing one or 2010, right? It makes a change directory. Let me put it in desktop. Export. And see it's loading over here. So we are done exporting it, and this is my desktop drawing one. Okay, so I'm just gonna minimize this, and then I will just minimize this too, and then I'm going to just open my AutoCAD. All right. All right. So now my AutoCAD is already opened, so I'm gonna minimize it too, and then I'll just click my drawing one over here, and then I will just open it. All right. So you say continue opening DWG. Yeah. So this is my drawing one. All right. This is my drawing one. So now I'm going to make this more visible by making the color type the white color. So I'm going to just click this and then um click and then just make it a white color and click OK. So I think everything will be affected. So let me just do it for this too so that we can see both. So just drag upward and then every other alphabet under that has a column text under that particular layer will be affected. So now I'm going to just go ahead and write all of this up. All right, so FC1, right? And FC1 is having this. That's 450 by 230. So now what you will do here is you have different type of columns over here. So I'm going to just name let's see all the loads. Okay, so the best thing we're going to do here is I'm just going to copy one of the text and then I'll use it for CO for copy, right? So I'm going to just use one text over here and then I'll just name it as some work. Let's name this as the um okay, let's name it as the rectangular column, right? So we have the rectangular column and then copy this to another place. We have the square column, right? The square column, right? So this is it. So now I'm just going to just copy this, copy and put it under the rectangular column. All right. So the same goes for this, copy and put it under the rectangular column. Then look for another. Let's check this polynomial. Okay, we have one here too. So you just select select, and then copy, and then put it under the rectangular column. Making it 4, right? So this one, copy under the rectangular column. Okay. All right. So we have the fourth one, right? So let's look for under rectangular column. Okay. So we have one over here too. So we are going to copy these two, put it under the rectangular column. All right. So show them again. Okay, I think that should be all right. That should be all. Okay. No, there's still more. Okay, that should be all. So we've picked everything that's regarding the rectangular columns. So now let's pick everything regarding the square columns. So I'm just going to pick this first. So copy. So put it here. And then there's the first one, right? Oh no. Okay, yeah. So I'm going to pick these two, copy. And then I'm going to put it here. That's the second one, right? So I'm going to copy the third one, copy. So I'm going to copy this, and then I'll put it here. All right. So the same goes for this. I'm going to copy it. So you have to do it very, very carefully, and also you have to take note of what you are copying, so you don't copy one of them 2 times. All right. So making how many? 1, 2. That's 4 square column have been selected. Right. That means we are at this point. So we just copy this one. Okay. So we can go this way. Copy, copy, copy. All right. So copy. Left with this, right? So we can just copy everything. Do you understand? So it's not something that you should be doing one by one. So we can copy everything and then just put it over here. These are the ones remaining, right? So you just select and then remove and put here. Select, then you move and put here. Do you understand? So the same goes with this. Select, then you move and put it here. Select, then you move and put it here. Then you select again, you move and you put it over here. Select, move and put it over here. Select, move and then put it over here. Do you understand? So select, move and put it over here. So right now, we are done sorting everything out that's into the rectangular column part and the square column part, right? So what we are going to be doing here right now is we are just going to be okay, let's see. Okay, let's delete the column type, all of them. So I'm just going to select all the column type, select all your column type. So that's the column test, sorry. So select the column test, all of it, and then just take it out, right? So we're having only the load that we need. So the same goes for this, select all of them, and then just take it out. So you are left with the load, right? So now these are the load that we need. We are going to divide this particular load into, we can make it just 2 group, but we have to study it very well first. So under the rectangular column, what are we having? What is the range of differences between the highest and the lowest? All right, so we are going to locate the lowest, I'm going to locate the highest. So 509.3 kilonewton, that's the load. 1689, we have 846, we have 16362, right? We have 791. Okay, okay. So the lowest is 509.3 and the highest is times 3 of that value, almost times 3, more than times 3 of that value. So 1689. What are we going to do now? Okay, let's have a range of from 509 to 846. All right, so under this particular rectangular columns, we're going to be having a range. So you can do it in other way, but just ensure that you know the part base type you are using for different sizes. All right, so for this one, we're going to be having just two here. That's two part base type, and this one two part base type, making it four part base type. All right, so follow me very, very closely. Um, so this is how you go about it to make your work very, very neat and so that you can organize everything and make it work fine. All right. This how to just go about it and to also maximize to make it cost efficient. All right. Just imagine that I'm designing everything with the highest load of 1689. Then I will have a more bigger part base for some columns that don't need it. All right, which is more cost because the more the size of the part base, the more the cost. All right, the more the size of the part base, the more the concrete, the more the reinforcements, and the more the material, the more the cost. So you see how you think as a structural engineer. So when you are just doing all of these, you just go ahead and make everything because to be easy for you. No, no, no. You are putting everything in place. The cost efficiency, you're putting it in place. All right. Very, very important. And also the stability of the structure, it should be your priority. All right. And the sustainability and durability of the structure should also be your priority. All right. So now let's see. Under this one, remember I said we are going to be having part base type, two part base type. So let's start with the square. Okay, so we have 452. We have let's pick the lowest. 452. We have 1081. We have 389.5. We have let's look for the lowest. Okay, 221. Okay, so the lowest is 321. So I'm just going to select this, and then I will just change the color. All right, so that's my lowest, and so from this lowest onward, that's not my lowest. Sorry, 32. This is it here. Okay, sorry. So this is my lowest, right? So from this one onward, I should be having let's say 5 of it. Let's say from 321 to let me see 429 890 1081 452 389 890 429 okay. Okay, so let's have a column type that has a load range from 321.1 to let's say 600. All right, let's say 600. So I'm going to just this is my lowest, right? So all concerning this part base type, I'm going to make it a separate color. So 321 321.1. Then we have, remember we are making we are doing it within the range of 300 to 600. All right, that's the first part base grouping. All right, so now 321 we have 767, we have 770, we have 460, right? We have which one again? We have 429, which is within the range as planned. So we have this and we have this. So I'm going to convert all of them to that particular color. And then that's for the part base type 1. So for the rest, I'm going to just select them. Okay, I'll leave it as white. Okay. So For this one, we are having, just follow me very, very closely, all right? For this one, we are having 509.3 as the lowest, right? So 509.3 to, let's say, 800. Okay, so I'm going to select this 509.3, 84. Okay, no. 509.3, then we have, okay, 791. Let's just pick this one alongside with it. Okay, so this is it. So now I'm just going to change the color type to, let's say, a green color. Good. So the other one, I can just change the color type to something else. Blue, let's say blue color. Good. All right. So you can see that we have the differences here now. I think this blue is not too visible. Let me make it something brighter. Okay. So that's it. So now I'm just going to go ahead and write the part base type. So we have part base type 1. That's the part 1 and part 2, part 3, and part 4. All right. So part 1 and part 2 will be under the square column. Then the part 3 and 4 will be under the rectangular column. Do you understand? So let's go ahead and do that quickly. So follow me very closely as we've been doing before. So we have copy this. I'm going to put this one here. I'm going to put this one here. I'm also going to put one here. I'm going to put one here. So you know the reason already, right? So we have our part 1, right? So let me just do this, and just move this over here. Part 1. So I'm going to copy this. So it will be easier for us. Remember your work, you have to be fast. So we have this here. We have this here. We have this here, and then I'll just move this. So we have what? We have part 2, right? So we also have part 3 over here, right? Follow very, very closely. We also have part 4 over here, right? So now I'm going to pick the lowest as part 1. That's under your square column. So pick this one. I'll pick this one. I'll pick this one. I'll pick this one. I'll pick this one. Good. So copy all of these and then I'll move them over here. Part 1. You see, right? No, let me just move them so we'll see it gone. So this one, I'm just going to move this and then I'm going to put it here. Good. So the same goes for all of these under, you can just say it with me, under part what? This will now be under part 2. Do you understand? So now we now be left with part 3 and part 4, right? So you pick the lower one under your square column, move part 3. Do you get it? So pick the last one, which is the highest load here, part 4. So you are done. Do you understand? So it's just to go ahead and just delete this. You already know that part 3 and 4 is your rectangular column, and your part 1 and 2 is your square column. So you have to put that at the back of your mind so that as you're doing your analysis, you will be inserting it in accordance. So now this is what we are having here. We've successfully grouped the columns into different part groups. All right, knowing that part 3 and 4 is the group under the rectangular column and part 1 and 2 is the group under the square column. So now we are going to head into our RCD and then do our analysis and get our analysis result and use the analysis result to design our part base. Do you understand? All right. So I've already taught you guys how to design that of the square, right? So I'm going to work on only the rectangular. Do you understand? This rectangular is my main focus here as regarding the part base. That's why I'm touching it. So I want to teach you guys how to design this particular rectangular part base. Do you get? So it's still the same template, but we are going to be working on it differently just to change one or two things inside, and then we are good to go. It's something very, very easy. All right. So now this is it over here. So we are going to still do our analysis as normal. All right. So you know how we go about it, right? So I'm going to convert this back to normal color. let's say by layer. Then these two, because we've already grouped it, right? Do you understand? We've already grouped it. So I'm free now because they are under their various group. So now these are this is it. So I'm gonna pick the highest number under each group. Do you understand? The highest number. So we are working with the highest number. Why? Because of the safety. If you go with the lowest, how will the part base of the lowest sort that of the highest? I don't know if you understand me. Imagine I'm going for the lowest. Let's assume I have a very high, let's say, where is it? Okay, let's say we have 429 load. Then I have 460 load. 429 load is lower than 460 load. I can't be picking this and use this to design my part base and then use that part base as the common part base for all this part group. And we have to go with the highest load, the ultimate load. When you are designing for the ultimate load. When you design with the ultimate load, the safety will be assured because no matter what, you are using the ultimate load. So whatever comes on that particular structure can be withheld with that ultimate load. If the English is too big, the highest load, the highest load. Do you understand? So let's go. So look at it here. So we are having 452, right? Yeah, we're having 389.5. We're having 429.3. We're having 460. Okay, we're having one highest. We have 321. So these are our highest load on that part one. So I'm just going to give it a green light. Good. You see it? A green light. So now I'm going to look for the highest load under part 2. We have one, wow, 1018. This one will give us the real explanation. Look at it. I can't be designing using this particular lower load to design my part base. You all know that the part base I will design with 890 kilonewton cannot withstand the load of 1018 kilonewton. Do you understand? So I'm going to look for the highest. You see it, highest. So that highest is this one. Do you get it? So you cross check again, cross check. Good. So this is the highest, right? So under this one too, you go with the highest. Please don't make mistake. Don't make mistake. Don't make mistake. Don't make this is a very, very critical part. That's why I'm explaining it very, very carefully. Don't make mistake. Yeah, don't even try it. All right. As a professional, you know where it's critical. All parts are critical, but some parts you don't even dare to make mistake there. So you're gonna have okay 1689. You see it, right? So imagine I take this particular okay, it's now visible 389 kilonewton. I will now go and design this particular part base using this particular load for this one. How will it be withstood? It cannot be withheld. Do you understand? So I want you to get the picture very well. I'm doing it like this. So I'm going to be using 1689 highest. Good. You see it, right? So this is it. So now I already have what I'm going to use for the 4 part basis. I have the highest. So now we can just Control S, save our work, and then we are good to go. Do you understand? So the next thing we're going to be doing now is to copy all this work into our working space. Remember, this is not our working space. We actually exported this particular one from Total Detail. So we have our working space where we did our general arrangement and everything. So we'll pack them into that place and start working in that workshop. Do you understand? So come on, let's. All right. So right now, I'm just going to our drawing one and copy all of these. Good. Okay. So Control C. Then you go into your project one, then you Control V. That's to paste. All right. So I'm just going to put that over here. All right. So we have it here. So you can see all of it. So we are picking this particular for our part one. We have 460. For our part two, we have 1018.1. Then we have for our part three, we have 846.8. Then we have for our part four, we have 168.9. Right. So we will copy our part base template. We'll copy our part base template. Let's look for a better one. Let me see. Okay. So let's copy this. So enter. All right. Good. So these are our part-based template here, right? Just a little work will be done on it. So I'm just going to head on into my part-based analysis and analyze the structure. Then we'll head on into this place, and then we do our part-based proper. All right. I've said to you guys before, we have different work to do. You can see our project one. We have different work to do. All right. So the way we did project one is the same way you do everything, but for this one I'm just going to be touching the pad base. All right, I'm going to touching what? The pad base and the staircase. All right, it's the reason I'm doing that, so that you guys understand how to do it proper in this particular scenario. Do you understand? There are different scenarios, you get. So in this scenario where you have different type of columns, you know how to do it. In a scenario where you have a kind of staircase, you know how to analyze it in RC 2000, not in ProtaStructure. Do you get? The project one, we um okay, we can analyze both your standard and input structure. So we just want to do both. We want to achieve the analysis using our RC 2000. Do you understand? So that's for the staircase. So we're going to touch that very, very well. Well, now let's just get going and let's see what we can get done regarding the part base. All right. So now I'm just going to head on into my folder. So in my folder, I'm just okay. I'm going to head on into my folder. Then I'll open my part base. Then I'll open my base 2000. Do you understand? So this is it. So now, as usual, as we did in project one, it's very, very easy. I make it as easy as possible, breaking it down with my words. Do you understand? So please enter the letter T. If the input is via keyboard, not you are saying terminal there, but it's via keyboard. You understand? It's the same thing. So T, because we are going to having our input via keyboard. Then they said that please enter letter A, letter P if the output is via printer or an external file. All right, so we're having a letter F for external file. So output file name, let's just say project 2, right? Or let's name it as engineer. Output file name Mr. Hillary Clinton. Okay, let's go Clinton. All right, let me not. Okay, let's say Mr. Clinton Clifford. Okay, so Mr. Clinton Clifford. All right, so let me see. Okay, so I'm ready. So password, no password. Job reference, job reference, job reference, job reference, job reference. Okay, let me use. Okay, so global job design engineer. So global. Your job reference is to your client, all right? Your job reference there is to what? Your client, not the company that designed. Your client. So I'm the client, I'm the designer. All right, so good. Your job, I'm seeing this again. Your job reference is to your client. Okay, design date. Let's say we have in June 2024. 2024, right? Okay, let's say enter number of part days. Now go back there. Go back, go back, go back, go back, go back. You'll be going back, checking. Hmm? To attain and organize an accurate work, it takes time and it's demanding. So we have one here, right? Part base 1, part base 2, part base 3, part base 4. So you go back into your, okay, so enter number of part base. So we're having 4 number of part base at the pressure of, let's say, this pressure comes from a soil report, all right? But basically, let's use 390. Pressure. 139, let's use 139. Or let's use 150. Okay, 150, 139, I'm coming. Let's use 150. Sometimes you can use 200, but it depends. 139, 139. All right, 139, 150, 140. You get. All right, so now we have our pressure, we have our concrete. For our concrete, we have 20, right? Then we have for our steel, we have 410. Okay, for our steel, we have 410. So enter. Then we have part base, enter base identification number. So we have our part one. Part one. Okay, part one. Then for my part one, what is my part one? Is it a square or a rectangle? So you check. Part one is square, right? Part two is square. Part three is rectangle. Part four is rectangle. That's why you go back there and then you hit the one. Square, right? Enter base type. Square. Okay, let's go. We can go with rectangle or square for both of them. Right, but no problem. So enter column type. Rectangle. One. You understand? Square. Enter column load, dimension, and dowel diameter. That's your bar diameter. We're having 460, right? That's the highest. Yes, we are going with the highest. We're going with what? The highest. So we have enter column load. We have in 460, right? 460. Then enter dimension. What's the dimension? We have 225 by 225, right? So for the dowel diameter, we have 16. That's your bar diameter. So we have part 2. Good. We have square and we have a rectangle. And then we have our load. What is our load here? For the 2, then we have 1018. You see it, right? So we have 1018. Let me check again. 1018.1. 1018.1 dimension 225 by 225 is still under square column 225 by 225, right? So good. We have our dowel, we have 16, right? Okay, let me check. Okay, good. So we have our part 3. We have a rectangle in this case. 2. Watch. Rectangle. You see how it changes, right? Enter. Then we have a rectangle. Enter. Then we have our column load. What is our column load? We have our 846.8, right? Highest value. 846.8. Then we have our dimension. We have we start with the breadth to 225 by 450, right? So our dowel is 16. Good. Enter. So we have our part 4. Good. Then we have a rectangle. We have a rectangle. We have column load. Column load is 168.1, 1689.1. So you go back into your work and then we have 1689.1. Okay. So we have our dimension 225 by 450. And then we have our dowel 16. You see it. So click enter. Oh, good. We are good to go. So enter for part 1, part 2, enter. So it's designing it. So he's saying that base area required is 4.22 square meter. Enter desired base length and breadth. This is where you go back and carry your calculator. All right. So you come into your utility, your calculator here. Right. So calculator. Good. So now you go back. What were they saying? They were saying I need 4.22 square meters, right? So I will need a breadth, the value of a breadth, that when I multiply that value of that breadth times the value of a length, it will give me 4.22. That's what they mean here. You understand? Do you get? That's why I say we should do this one. You guess how you guys understand this particular aspect. It's not all as you think. So we have 2.1. Let's say 2.1 by 2.1. Let's see what will give us first. Good. 4.41. What if we go with 2.1 by 1.9? Let's try it. 2.1 by 1.9. 3.99. It's too small. What do you go with? Let's say 2.3 by 1.9. 2.3 by 1.9. 4.37. We are looking for 4.2 what? We're looking for 4.22. It's better for it to be 4.3 or 4.25 than for it to be lower. You understand? So let's go back to our calculator. Okay, I know what to do. 2.3 by 1.8. Then let's see the result. 1.8. 4.14. Okay, that means we are heading for a two decimal place. 2.3 by 1.85. You see it? Sharp. We've gotten it. So 2.3 by 1.85. So we'll go back into our RC 2000 and we have 2.3. What they say in meters, right? Say in meters. Yeah. So 2.3 is in meters. Length times breadth. Okay. So yeah, 2.3 by 1.85. Do you get? So we enter the length and the breadth, and then they say good to go. We click OK. So enter. For the other one, they say they need 8.43 square meter. Now we've done that of part base 3. We are entering part base 4 now. They say they need 8.43 square meter. Let's go back to our calculator. I don't know. Follow me very closely because you will need it. You understand how I'm sure we are taking, we are going this extra mile teaching you this. Look at it. 8.43 square meters. 8.43 square meters. So I'm just going to say, okay, let's say I'm going with I don't want something too rectangular. All right. I want something close to square, but not a square, but rectangle part base. So I'm going to go with 3.9 by 2.2. Let's see the result. 8 point what? Let's see. 8.43 and 8.58. So we can use it, right? Or we should get something closer. And let's try. Let's not just go with what we have. 8 point. We did 3.9, right? Okay, let's do 3.9 by 2.25. Let me check again. I'm coming. Let me see. 8.43. Okay. 8.43. Okay. Let me go with 3.7 by 2.2. Let me see the results. 8.14. 3.8 by 2.2 should give us 3.8 by 2.2, 8.36. Okay, 3.8 by 2.25. Let's go with 8.55. 3.8 by 2.25. Okay, so 3 point, so that was a comma. 3.8 by 2.25. Then the diameter. So I click enter. So we are good to go. You can see control. That means everything is done. So you can easily exit this and go back to your folder. So in your folder, you will have it there. I have what under my part base. Where is our work? Okay, Mr. Clinton, right? So this is it here. So I'm just going to open this. I will see the results. Then using the results, we are going to work on our part base. Do you understand? So using the result, these are our results over here. So we are going to work on our part base using this result. All right. So come on, let's go and work on our part base, and then we are done with part base. So I'll teach you guys that part of the staircase. Then please make sure you complete your work. Complete all your work. The same way we complete our work in project one. Complete your work here. Do you get it? All right. So now this is it. So with this analysis, we are going to create our part base. All right. So follow me very closely. Let's head on over to AutoCAD and create our part base. All right. Okay, just one. So now, um, okay. So now, as I said earlier, follow me very, very closely, right? So let's go. Now, the first one is part base one. Good. Okay. So we have, uh, let's go up to part one. So we have part one here. Look at it. Part one, right? So so the part size is 1550 by 1550. So the depth is 400. All right. The depth is 400. So let's go into our work. The depth is 400. So I'm just going to copy my template, copy this template and put it here. Remember, I was just working on it separately. We have our templates here. All right. So now we have this here. So let's check again. 1550, right? So we have 1550. You understand? 1550, right? So dividing 1550 by 2, you'll be having what? 725. 725. So you have over here too 725. Then you have over here we have 725, right? So follow very closely as instructed. We have what? 725, right? So for this one we have what? 1 1 1 550, right? Okay, so the same goes for this other point. We have what? 1550. You understand? So now the next part is our part base depth, which is 400. All right, so that's the details we checked for now. So let's go and check other details regarding part base one. So we have 200 mm, so that's Y12. Then for the first one, parallel to 1550. Then we have parallel to 1550, we have the same thing, 200. So on both sides, we are having a main distribution bar, a main bar and a distribution bar as uh, as a spacing of 200, right? So you just come to this place and just insert your 200 spacing, 200 spacing, and the same goes for this point, 200 spacing. All right, so you're going to divide. So with in doing that, remember we have to create a here, right? So we are going to divide this. We have 1550 divided by what's our okay, divided by, let's say 200. Maybe our result 7.75. So we are going with 9. Right, remember you're adding one bar. All right, so it's going to be 9 for both sides. Good. You see it, right? It's going to be 9 for both sides. So it's column base 1. What is the number? It's very easy. Come back here. 1 2 3 4 5. Look at it. 1 2 3 4 5. So you are using this highest number design for everything. So you're having, what is the column number? How many columns are carrying a particular part base type? We have 1 2 3 4 5. You can still get it further when you do your complete drawing. All right, remember you're doing your complete drawing. This is not the complete. The way we did it in project one, that's the way you replicate it here. Just that this part is very delicate, so I had to just come back and say, okay, let's talk about this part and also talk about that staircase area. Do you understand? So let's go. So look at it now. Okay. So we are having how many? We are having 5, right? So I'm gonna count 1, 2, 3, 4, 5, right? So let's go back. So we have 5 number toss. You understand? So now for this we are having 9. So let's count 1, 2, 3, 4, 5, 6. So I'm just gonna delete this. There's no need measuring. All right. So just put the representation. So I'm going to have 7 in between, right? So I'm just going to copy this, copy this and just enter, and then I'm going to just copy from those points, from one point to another point. So we have 1, then we have 2, we have 3, okay, we have 4, we have 5, we have 6, let me see, 3, 5, okay, no problem. So just move this to this point, then just drag it, then just copy this. It's just a representation, right? So now count. Let me just adjust this a bit, even if it's just representation. Let me just, with my high view, I'm trying to make it accurate. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're having 9 here too. Look at it, 9. So it's this bar that you are seeing. So when you cross section, you are seeing this particular bar. All right. If you could show this part, you see this bar too. All right. So we are done with 1. So it's the same thing for your that square type. Look at it, this one, part 2. So you do the same thing for part 2. Don't jump it. Okay, let's just do it. Let's do it because some of you will just ignore it. We have 4 parts here. This part 1 is the same process of part 1 that you use for part 2. All right. So part, okay, let's leave it. You guys will do it. Look at it now. Look at it. Part 1 is the same as part 2. So the same process you apply for part 1, create this particular part base for part 2, picking a reasonable template here. Please take note, reasonable template. Design part 2. Do you understand? So let me just write it here because of how delicate it is. So we have to go in that delicate way. So copy. So I'm just going to copy this. For those of you that we ignore project 1 and come and watch project 2, we hid some things in both projects that it will be very important to you. So you go out back and watch all of them. All right. So we have assignment. Design the part base of part 2. You see it, right? So you guys will see it that part 2 is part of it. So you're designing that of part base 2 as your assignment. Do you understand? So it's very important for you. So we have part base 1 here. Look at part base 2, the one that you do as your assignment. Then we'll go to part base 3. So for part base 3, we have the template here. I don't think it was this template in the template I sent to you guys. Okay, don't worry, if you don't see it there, just send me a DM. You know you can always talk to me. All right, so I'm going to copy this template. So I'll copy this template and then I'll put it here. You see it? So then I'll put these here. Okay, so let's go. Remember, we are working on part 3 now. Part 2 is for who? Part 2 is for you. Okay, so now for our part base 3, we are having 2300 by 1.85, right? So you go back into your AutoCAD and just the same thing. There's nothing different. All right, 2300 divided by 2 as 1150, right? 1150. Then we have 11502. Then we have, what is here? What do we have here? We have 1850, right? Let's check. We have 1850. Okay. So sorry, that shouldn't be there. It should be here. So we have 1850 divided by 2. What are we going to be having? We'll be having 925, right?
925. So we'll be having 925. So for this one, we are having what? 2300. So you see it, it's as easy as that. 2300 divided by what is the spacing and also what is the depth they are giving us there. I think that depth should be up to 450 or 500. I said it 550. You see it, Abby? So because of the load, all right, because of the load. So 550. Okay, so 2300. What are the spacing? So you now see the importance of this one now. You see it parallel to 2300. Now go back. Parallel to 2300. Look at it. Parallel to 2300. What are we having? We're having what? A spacing of 125. Go back. A spacing of 125. Parallel to this it. Parallel to this one. So we are having this one. You understand? This call out. Let me see. This is a call out. Okay, so this call out. Do you understand? This particular call out. So now look at the donut. Parallel to 2300. So this is the reinforcement. So what are we going to do now? We are going to just edit that. So this is the reinforcement here. This is the call out. So for this call out, we are having what? 125, right? So what is the 2300 divided by 125? What are we going to get? 2300 slash divided by 125. What will be the answer? 18.4. Wonderful. So we are having 18.4 here, right? So we are having 18.4. That make it let's say 20. All right, because of the one additional bar. The same goes for this one. So let's check our analysis results and let's see. We have 150 parallel to 1850. So you come back here 150. So we have 150, right? So we have 150. So we have 150 parallel to 1. Let me see. 1850 divided by 150, right? So go back to your calculator. You have to do this very carefully, please. No mistakes. No mistakes. No what? No mistakes. So we have 1850 divided by 150 equal to 12.33. So let's go 14. All right, to be safer. So 14. So we come here and we have 14. Good. So now you can see. So we have column part base 3. What is the number? 3. How many are there here? Let me see. 14. Let me count this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're having 12 here. So we'll just add additional 2 to it. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so it's now 14 over there. Hold on. I'm coming, please. Okay, look.
Something is going wrong here. Let me check properly. This spacing, this particular reinforcement, and this one, this call out, sorry, this call out for this one. All right. So 2300 divided by this reinforcement. All right, this reinforcement here that is spanning through from this point to this point. So something went wrong. So we're going to edit it. Just move this. All right. So take note, please. So just move this, put it here, and then it's supposed to be like this. Okay. So please take note of that, please. So we're having 20 here instead of that number. So instead of 14. All right. So take note of that. So it's supposed to be 20. Good. So let's go copy. We have 1, 2, 3. Okay. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Let's do it complete. Okay, let's copy again. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. That's too much now. Coming. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 14, 15, 16, 17. Okay, so now it's complete. 20. Okay, so now this is it. So you go ahead and do that of this one. Please be very careful. I word very closely. Okay, so now we are good to go. What's the number? We are having part base 3 is what? 1, 2. We are having 3 number. Okay, 3. All right. So we are good to go. Now, do assignment for what? Part base 4. Design the part base 4. The part of part 4. Let me change this minority. Design the part 4. Design the part 2 and design the part 4. Okay. So now let's head on into the staircase and let's see what we have to do in the staircase area. It's going to be very detailed and enjoyable.